Hello and welcome to the next edition of the Hack the Planet podcast, the only podcast in the comedy category that averages less than one joke per episode. We're well, there wasn't a bitter sarcasm category, so I got a little confused by the ontology. We are joined today by legendary hardware security trainer Joe Fitzpatrick, although the Patrick
Hello.
is usually silent. Say hello, Joe.
Hello.
Hey. We are also joined by our usual panel. We have Mitchell.
Hello, everybody.
We have Max.
Hey.
We have Virus.
Hello.
And we have Justin.
Hey guys, it's good to see y'all again.
Hey. So, Joe, how have you been?
Pretty good. Surviving. Enjoying the fact that I haven't traveled anywhere in nearly a year and a half, or over a year and a half at this point. So kind of a different pace from what I'm used to.
Yeah, so normally you're going around doing hardware security trainings all over the place. Like, what's your normal travel schedule like?
I try to keep it to one trip a month, or I used to in the normal days. And I never really did a good job of that. So it usually ended up being like 1.5 to 2. And so sometimes when one of those trips would be 2 weeks of training back to back, it got pretty hectic. Yeah, I've actually on my second time that my office has been clean ever, both times in the past year and a half, because I don't get home, drop the bag, and start packing the new bag, and then come home and drop the bag and start packing a new bag, and then finally get home and have a month where I didn't book anything, and I have like 8 bags that I have to go through to unpack.
So you weren't always this busy. Like a few years ago. How long have you been doing the security training thing?
So this is 9 years now that I have been independent, running my business, doing this, and it's pretty interesting because it started off like any business starts off relatively slow and has built up over the years. But 2019 was. 2018 and 2019 were at capacity. And I kept wondering, like, oh, is this when I'm supposed to back off? Is this when I'm supposed to back off? But it's still going good. And luckily, the world decided it was time to back off in 2020. And I was ready for it. So no complaints there.
So how did you get into hardware security training in the first place? Like, it's a relatively small niche. It's like you and maybe Joe Grand and
Colin O'Flynn, a few others. Yeah. So I was working at Intel. I started out in the product the silicon debug group, and moved into the product security group. And I don't know that I was actually very good at what I was doing at that point in time, but that's an aside. We started needing to train a whole bunch of people. So everybody who was a functional validator for silicon needed to understand what a security bug was. Because if they didn't, they would just file their bugs and ignore them. And there was a small group of us, the product security team, and we were supposed to go and look through and find look through all the bugs that are filed and figure out which ones were security relevant. So what we started doing is training the entire validation group to identify what a security bug looked like. That way, they could click a button in their bug report filing that said this might be security impact. And then instead of looking through thousands of bugs, we look through a few hundred bugs that have that flag checked. So I didn't make that training material. One of my colleagues did, but I really enjoyed teaching it. And when you actually have a course that's a required corporate training, and to get people to actually get to the end of the class and be like, wow, that was a good use of my time. That I think is an achievement, right? And I was able to do that. And what I wanted to do, though, I wanted to be doing hands-on training because this was a purely lecture-based class, and there's so much to hardware that you can be doing hands-on. And I had been at Intel for long enough that it was time for me to look at different directions. And I decided I was on parenting leave. I went to my first DEF CON, and I went into the hardware hacking village and saw the state of hardware hacking, which was great. There's a whole bunch of people doing hardware hacking, but it was limited. It was soldering, it was flashy lights, it was some basic stuff. And I'm like, there's so much more we can do here. And that's when kind of the whole idea congealed. And within 2 months of my first DEF CON, I guess I had left my job and started a business. And I was giving a workshop at the Hardware Hacking Village the next year, and then the following year I was giving a class at Black Hat. So like one thing led to another pretty quickly.
Was it really different, like teaching? I mean, I imagine you get a fair amount of software people who are like in some of these hardware classes now, and I mean, like you mentioned earlier, like being at Intel, where like you have these people who just do validation, like that's a normal thing, and like there's a little bit of that in software, but like not like there is in hardware, right? Like no, you validate stuff, right? And so you're like more teaching like QA people how to do security as opposed to teaching security people how to do security different. Like, does that like that's got to be weird because like software does not get tested like hardware.
And it's funny because even the classes I teach now, I try and pitch them as saying that like, yeah, this is for that realm in between. You have hardware people and you have software security people, and there's a gap in the middle. And so I want to take all the hardware people and bring them in and give them the security skills. And I want to take the software people and bring them in and give them the hardware skills. And so I can use the same training material for both of those audiences. So as long as I ask them ahead of time, I include the right anecdotes and tangents, and it comes to a nice spot in the middle. And the group I was working with at Intel was a lot of software security people pulled into the hardware, and I was one of the oddball hardware people kind of pulled into the security side of things. So there's both groups of people, and the savvy hardware hackers and hardware security people come from both sides. So yeah, it's different, but it's not that different.
That's cool. It seems like it'd be harder because like hardware definitely scares me.
It's like that Venn diagram of like, what you know and what people know. Like you're just finding the overlap or finding the gap in the Venn diagram and filling it in. So it doesn't make a big difference which direction from.
Might have to take the plunge and take one of these trainings someday, because it definitely seems really daunting as like a software person. Because I think about like how big the Venn diagram of just software is, and it's like on the one hand you have like OWASP stuff, and on the other hand, like the far end of that pool, you get into like loaders and debuggers and craziness, right? And it's like when you're at the debugger part and you're staring like somebody who's just starting in the face, and they're like, I want to do that. It's like you want to give them all the things, but you also don't want to scare them, right? Because like there's this giant chasm, and like it seems like, and I don't know this, right, because I'm not a hardware person, but like it seems like on hardware that has to be like the same problem, only like 5 layers deeper, right? Because it's like you're not just teaching hardware, you're also teaching at some level like physics and like a little bit of chemistry, and like it's just goodness.
It is a really big space, but there's a lot of kind of easier to access stuff on the surface that gets used a lot more frequently, like making a serial connection to something, or like using JTAG or whatever, versus like EM probe side channel analysis or whatever on the high end, or like laser fault injection or whatever the cool kids are doing these days. I am kind of curious, like how kind of the courses you offer and the sort of the content of the courses has evolved over the last 9 years.
So the very first workshop I did was a like beginners side channel attack on a keypad entry system. That's the workshop I did at DEF CON 8 years ago at this point. And basically you're using a logic analyzer, which is a hardware tool. Once you understand how to use a logic analyzer, you realize it's an observation tool. It lets you watch things, and then capture data, and you measure it, and you can draw your conclusions. Pretty interesting. I'm just still thinking about the whole like software hardware gap. But what actually turned out to be the most alluring was basically the EE hardware hacking 101. Like, what can we do to get your hands on hardware, find things, and hook up wires to them? And that's like finding UART ports, finding SPI, dumping firmware, getting JTAG. And so even though like my prior background was like silicon debug, like where we had a lab with several fib machines, so we can go and edit chips to go and run on a system while we examine them we hit them with a laser to do manipulations, right? That's what I've been doing for years. And suddenly I get out and I'm teaching people like UARTs and JTAGs, which I really enjoy. It's the introductory stuff, and it's also like the gateway. I didn't realize how much a need there was for that gateway information. So that's great. It keeps me 100% busy. I keep trying to make these advanced classes, and they're great, and I think people enjoy them. But like no matter how much effort I put into advanced classes, that one introductory class is 50 to 90% of my work because of the number of people who want and need to go through it. You have someone with a strong software security background, and they take that introductory class. It like opens the door for them, and then they just dive in and they can do all sorts of things. They don't need the advanced classes, right? Because they've got the stepping stone, they've got the foundation to work on. It's the people actually more the hardware side of people who need the more advanced classes because they need to understand the security implications of the greater issues.
That's a really good point, because you were like my role model for training in general, but also hardware training specifically. And so sometime after, so I went through one of your trainings at one point down in Portland years ago. And then sometime later, I ran into you at DEF CON the first year Hari did the voting machine village. And we were hacking one of the voting machines, and it turned out to be an ARM5, and no one had a dongle that worked on anything less than an ARM7. So I was like running around DEF CON getting blisters, looking for anyone that had an OpenOCD compatible dongle, and I caught you still wheeling your carts around from your black hat training, and you were like, "Here, have this FT232 dongle." And then we went and like dumped the firmware of the voting machine, which was the first time someone had dumped that firmware. We found a bunch of bugs in it. It was a very good time. But I went home after that, and I started doing this hardware hacking workshop, which I just put on Meetup, and I don't charge anybody, and I've been doing it once a month ever since. And people show up, and they're just total beginners, and I'm like, "Hey, would you like to learn how to hack a voting machine? Like, I can get you up to getting JTAG on a voting machine inside your first session, And I always thought, like, hey, if people keep coming back, like, we could eventually get up to some more advanced stuff. But it kind of never really. Sometimes there's smaller groups that come that are more advanced that go off and do something else. But it's really like everyone who shows up really just wants that kind of beginner, like, how do I get a serial connection? How do I get through using OpenOCD for the first time, which is traumatic, and it's good to have.
That's extraordinarily traumatic.
It is a terrible interface. It was written by someone that hates people. But what you were saying is that, like, if you take a software security person and you show them how to make a UART connection to a board, odds are they're like, "Oh, hey, it's a root shell. Like, I don't need you anymore. Like, I'm gonna go." Exactly. I know what to do with a root shell. Like, now we're back in, my happy space.
I basically had that exact experience. Like,
yeah.
Like the very first hardware thing I ever did was Goodspeed teaching me how a GoodFet worked. And like, I used it and I got firmware. And then I was like, oh, now I have binary. Oh, I know how this works.
This is root shell. I know root shell.
Yeah.
I mean,
this is Unix. I know this.
Yeah, exactly.
Well, that was actually a direct quote from someone at the last workshop, right? Like they got a shell finally on a DSL modem, and they're like, "Oh, hey, a root shell," and they were like, they just started tuning everything out, and they were like just typing. It's like, I know what to do with this.
The one fun part you get to, though, is you get the people who have done a lot of stuff on like full stack Linux operating systems and Windows operating systems or anything else. And you give them a root shell, and they're like, "Oh, I got a root shell. I can do all this stuff." And they start typing in their stuff, and like all the flags they use on Netcat are gone.
Yeah.
BusyBucks on Netcat.
Yeah.
And then they're like, wait a minute. And they're like, "Oh, let me just edit a file." And like, there's no text in it, and not even Vim works. And they're like, "Wait, how?"
Yeah.
And then, of course, they know how to get around these things. It's just, they get so used to the set of core tools you're used to that, like, suddenly you realize, oh, embedded, you don't necessarily have much. You have BusyBox, you have stuff. You have to go and use shell redirection to rewrite your files because it's just easier that way.
All the joy is behind the phrase, "What is BusyBox?"
And the whole what is like what the fuck is BusyBox? These are all soft links. What's going on?
The one that always gets me is just LS is never featureful enough on BusyBox.
Yeah.
Oh, and PS. Oh man, it only does Unix or the BSD options.
Or my favorite is I was messing with SSH and I don't know what drop error is. And I'm just like, "Oh, you're in for some fun."
But like U-boot and BusyBox are all like people are like, "Oh, it's U-boot. I know U-boot," and it's like, yeah, but U-boot and BusyBox are just giant switch statements that are like configured by a config file that everybody just goes in and like comments in or out, whatever it is they want. And then they make horrible customizations. What?
Forks and customizes and doesn't re-release. And,
Oh yeah.
Yeah. So it's like, yeah, it's pretty unpleasant. So that is like the next thing. But the thing is like if you have a software security person, you know, it's just like a new Linux distro. It's a bad Linux distro, but it's like you know, it's like when they see a new Linux distro, it's like they kind of know how to figure that out, right?
Yeah.
It's kind of not a hardware issue anymore. You know, so when you were kind of learning how to teach, when you were kind of figuring out how to do trainings, like how did you sort of figure out what to do? Because having gone through one of your trainings, I can say that you are the way you organize information is very good. Like it's better than I'm constructing the question here, but everything's very, you know, like structured in a certain way. Like there's clearly an intention behind it, you know, and I'm kind of wondering sort of what your theory is or how the theory's evolved.
So very little of what I teach in my classes, you can't just go on YouTube and find someone to teach you as well. Like it's there. There's no magic secret anything in all of my training. But I think what I do is I curate the material. So you can spend, you know, 3 weeks on YouTube, and in that 3 weeks, you'll probably get like, you know, a few hours worth of good material that's factual and current and relevant and makes sense. You'll watch some stuff that's beyond your understanding when you watch it, some stuff that's remedial. So what I kind of do is I try to get the flow from beginning to end and have it be like near guaranteed success, but not step by step, not spoon fed. So, and actually it builds on that even more. So the idea is like, okay, if you've done something once, you know it's possible. When you know it's possible, you know how it's supposed to work, you know what the right path is. Then suddenly if things go wrong or things don't work smoothly, then you know you recognize when they're not working smoothly. You can identify that, you can fix it, you can move forward. And so kind of try and start with the smallest, like step by step, follow this procedure and get this exact output that's like foolproof. And then each lab successive, you build beyond that, but you get less hand-holding. Does that make sense? And it seems to work. It's kind of funny. My wife is a Montessori teacher, and they've got a very similar concept that they use in those classes where you explain something, you show something, and then you have them do something. And it's basic. Like anybody is like, oh yeah, of course, that's how you teach things. But the reality is that, if you stick to that like very simple structure of organizing stuff, it comes out a lot better. The other part is actually having a good idea of what the objective is at the end. So like when I'm discussing UART, I want your end goal to be, you know how to find pins, hook up to them, start up a console, and send some commands, right? And so once we've done that once, like let's be able to do it a second time and actually take each of those steps to do it. So that's kind of a bit of the mindset that goes into how I sequence the information and put it in order.
Yeah, as someone, I took your training sometime around 2018. The one thing I also wanted to comment on was you always had a very interesting selection of targets, which, you know, someone just sort of playing along at home, they might not have a stable, you know, set of targets that they're trying to, you know, work through. It's not as well pre-baked, but especially, I won't give away the ending of some of the stuff you used to do, at least, but there were just some interesting aha moments about just like, oh, I didn't know that could be a pin, for example, for some other dual purpose feature, etc.
I know exactly what you're talking about.
Yep.
Yeah, so it's funny because, you know, when you're working as a pen tester or you're working as product security, you don't have a choice about what you work on. Whereas where I'm independent and my sole purpose is to create training, I buy a lot of hardware that I take apart, and it's actually fine for me to like say, it's too hard, move on to the next thing. So I get to pick out the good stuff and make use of it. So, you know, I pick a Wi-Fi router that I can get reliably, inexpensively, and in high quantities, and has all the things lined up just how I want it to, but it's still an off-the-shelf router. Actually, it's for the new class I've been working on. I actually went all out and made a custom target. It's the best thermostat, model F. Disclaimer on it says assembly required, disassembly prohibited, unauthorized use prohibited, qualified professional installation required. Read all enclosed disclaimers before opening. Warranty void if used. Warranty also void if unused. Pay no attention to the Raspberry Pi behind the label. So it's a little like mocked IoT thermostat with obscured chips that is like a hardware reverse engineering target. And so for that class, you have two targets. One target is an SSD. The other target is this contrived thermostat. And between the two of them, I give a demonstration of a process on another target. I talk about the pieces of the process, and then we have two separate examples where you go top to bottom and repeat that whole process. And so it reinforces process, and that's kind of one of the difficult things. If you've never done hardware and you look at a hardware problem, you're like, oh, where do I start? But if you have a process and you've done it 2 times, then like, hey, worst case, I'll just walk through the steps. It's like, just show up and look pretty, and everything else will be fine, right?
Yeah, like for my workshop, I basically just buy stuff at Goodwill, or I find it in a dumpster, and then I bring it in and hand it to someone, and I'm like, pop a shell on that. bit less preparation.
The annoying thing about Goodwill lately is I noticed they will price electronics based on size. So like the big routers are $25, and the big routers are the old ones, but the recent ones are the cheap ones. So if you want to, you go to pile routers, there's a bunch of small ones that are like AC and N, and those are $5. And then there's the big WRT54Gs, which are 802.11b or G, and those are $25. Just funny how they end up doing that.
But the big old ones, I think, are easier for beginners because they actually have pin headers or populated or unpopulated. It's a lot easier to connect to serial, at least.
Do you have any good tips on connecting to pogo pin pads arbitrarily on?
I was going to ask that too.
So if you make your own bed of nails, it's pretty easy.
How do you survive without micro positioners?
Right.
So I have one of the PCB byte. Is that what it's called?
Yeah, I just got one of those. It just came in the mail because Max showed me his the other day.
Yeah, those are pretty great.
Yeah,
it's pretty neat. But like, I find most of the thing, at least for the nature of my work, if I'm doing something once, I'm going to do it 100 times, right? And so the SensePeak is good for 1-off, 2-off. So for Tigard, this little orange board.
I'm sorry. What's a Tigard?
Tigard. It's weird. The wonderful thing about Tigards is that Tigard is a FT2232H based breakout board. But it's got pinouts for all the headers I use in my class, and then some, which are pretty much all the interfaces you're going to use in 90% of your hardware hacking. So it does UART, it does JTAG, it does SWD, it does SPI, it does I2C, and it's pretty much it works with existing software. So like I didn't have to write any code to turn this into a product, which is great. And it basically has all the features that I wanted that no one else was making. So I finally just broke down to make it. This is what happens when I don't get to travel, right? And actually, the payroll protection program, so that was pretty great because I got a payroll protection loan. I actually hired 2 interns over the summer. We all worked together. We designed a PCB, got manufactured, put it on crowd supply, and sold thousands of them. So yeah, kudos to that. So
so what is it named after? I feel like it's like a Norse myth I don't remember or something, or a ship. Was it a ship?
So the chip on this is made by FTDI. FTDI's global headquarters is in Glasgow, and their US headquarters is in Tigard, which is right down the street from Portland.
Oh.
There is another project called Glasgow right now, which is an FPGA-based board based on a Lattice FPGA, whose headquarters is in Hillsborough, just down the street as well. But that was basically the desire to replace everything people are using FTDIs for, which is a great mission, but it's a little higher price and a little more advanced than what I wanted. I wanted something very simple and inexpensive. So yeah, I figured I called it Tigard because it was the next best thing to Glasgow. So
I get it.
Nice.
Yeah, I have one. I keep it in my bag mostly just because it's, it's small enough, along with the bit magic that you can get, at least at the crowd supply. It was coming with a pack as well. So nice little small form factor logic analyzer. And I've been using that at the hardware hacking workshops for things. And it's, reliable, intuitive. So just
The
great job on the
Yeah.
execution.
the
It's-
2232 has 2 UARTs on it too, right?
Yeah, the 2232 has 2. So what I have is one of them is set up as the UART, and the other one is set up as JTAG SPY
Gotcha.
I2C. And they have level shifting, unidirectional level shifting, so it actually works, unlike bidirectional level shifting, which is black magic and never works. And so
I think I saw you post about that. I don't quite understand why bidirectional is always so bad.
Do you want me to get into it?
Oh yeah,
A little bit, yeah.
go
So
ham.
the idea with bidirectional level shifting is you have a chip that's supposed to sense the voltage on one side and propagate it to the other side.
Yeah.
But you're also telling that chip at the same time it's going to take one voltage level and change it to another voltage level. It has to be aware of the possibility of taking that other voltage level and changing it back to the first one, right? And it's supposed to do this at high speeds. Like the FTDI can go up to 30 megahertz. So it just doesn't work. It's fine for I2C, which is supposed to be bidirectional. It's designed to be a bidirectional protocol. Yeah. It works at SPI for really slow speeds, and it really doesn't work well for anything else. So if you want it to be robust and work, just
So is the issue something like if it gets all zeros or something from one side, it could dynamically decide that it's shifting voltage differently or something like that?
Well, so if both sides are 0 volts, then that's easy, right?
Right.
If one side goes up to a high voltage, right, it has to drive the other side up to a high voltage. But it has to not do that if that other side is actually being driven to a low voltage, right? Because if the other side is being driven to a low voltage, it needs to pull the first side down to a low voltage, right?
So if the low voltage side is writing all ones and the high voltage side is writing all zeros, maybe it decides they're swapped?
Yeah, it's complicated.
The a conflict of because you're basically using a MOSFET or something like that to do the voltage switching, so that MOSFET has no concept of the intent of the circuit. But it works for unidirectional one way because you're only one side is driving, so there's never a conflict of. Okay, that makes sense.
Oh, I was just going to say TLDR, black magic fuckery.
Yeah. Not the black magic probe. That's a different tool entirely.
Once MOSFETs are involved, it's always black magic fuckery.
It's true. And I mean, the neat thing about the Tigard too is that you can also use it as a bike reflector.
It is orange. I don't know if it's reflective enough though. Well, it's funny. I wanted to. If I'm like, okay, if I'm going to make a bunch of these, I'm going to make a bunch of custom PCBs. If I'm going to do that, I should be able to lobby for like a custom color. And so the factory that said, like, I asked, oh, can you do custom colors? And they said, what Pantone do you want? That was like, you're the factory I should go with. So,
whoa. So literally you could pick any RGB value?
Pretty much.
And
they mix it. The downside is it's a very thin solder mask, like viscous solder mask. So it doesn't tent the vias very well, if that makes any sense to anyone.
Yeah.
When you have holes in the board and you put the solder mask over it, it's supposed to like bridge over the holes to make it nice and smooth. But this one does not always do that. There's often a lot of little gaps. So trade-offs. I'd rather have it orange with untented vias.
Very cool. So that's your first. Is that your first? I know it's your first commercial hardware project. I imagine you've had. Actually, I remember you used to make little boards and hand them out at conferences for a while.
Yeah, I haven't actually like sold any hardware though. Like despite being a hardware person, I will say there's no money in hardware. Right?
Yeah. Manufacturing
and selling hardware, that is not a business I want to be in. I know people who are in it, and like I have a lot of respect for them, and that's great. But like, that's not my business.
Is it? It's just a matter of scale, right? Like,
yeah.
Like all the people making money in hardware are just like huge entities.
And if you get any moderate degree of success, then China might copy you.
Yeah,
exactly. People who
like I said, it's a matter of scale.
Exactly. Well, that's okay. So really, if someone went and copied Tigard, right, and started selling them at cheaper than I could manufacture them before, that'd be great because then I just buy them from them, and I wouldn't have to blow it off of my shoulders. I wouldn't have to support them either, which hasn't been a problem and not a big deal. But like that's my personal perspective on it.
So despite that, you've got another hardware project cooking.
I do.
And it also has a name that vaguely makes me think I've forgotten about a myth. So it's Erebus, right? And yes, that's like I remember Cerebus, but Erebus was a ship though, right? That was a ship.
Cerebus's father, I believe.
Oh, really?
So
did he have 6 heads or?
This is a PCI Express device, and it's not just me. I'm working with Peter Eston-Temsky, who has a company, 1Bit Squared. They make the Black Magic probe and the Bit Magic probe, logic analyzer. So I've worked with them in the past, and he also helped with Tigard. But it's a PCI Express device, and we wanted something that was like PCIe something. But PCIe is an anagram for Epic, right? Okay. So might as well have Epic in the name.
All right.
And then we're like, okay, Epic what? And like we're trying to come up with names, and so we ended up with Epic Erebus being the name for this device. And Erebus is like the primordial god of chaos or something in Greek mythology, father to the Titans, or
sounds like PCE to me or PCI to me.
Yeah. Basically, it's a hot mess. So my idea at first is I wanted this to be the small form factor as possible. It's FPGA based, so we don't have to deal with limitations of a certain bridge chip that may or may not be available for a long time. So it's based on the, what's it called? Lattice ECP5.
Oh, really?
Which when we started was readily available and is not anymore. As soon as we finished the board design, I was like, whoa, we got to figure this out. And I actually went and spent thousands of dollars buying all the FPGAs, all the socket compatible FPGAs I could. So we have enough for their prototyping over the next year. Awesome. Because if we didn't, we're stopped. We have nowhere to go. We basically have to go and buy dev boards and pull chips off of them just to do test and development.
Go over to Hillsboro and just steal a truck.
Yeah. So yeah, it's ECP5 based Lattice FPGA open tool chain, and it sits on PCI Express, and it's an M.2 form factor. So M.2 AE, like a little wireless Ethernet adapter. Okay. And we're tinkering with it to make it actually, instead of the release version may not just be M.2 AE, but ABE. So it'll fit in some hard drive slots as well.
Nice.
So. And yeah, it's a small PCI Express device.
ABE, you get only 2 lanes of PCI Express, right?
So AE, you only get 2 lanes of PCI Express.
Okay.
But what's really weird is the spec is very unclear, and it's actually the only implementations of it are 2 separate single lane interfaces. And that's Google's Coral AI. There's a little implementation of that. So it's 2 PCI Express devices on one board, which is kind of weird. The spec is unclear, ambiguous as to whether you can do just one X2 device. But the thing is, because it's such a small form factor, you can get an adapter to put it into M.2 BM or PCI Express or mini PCIe or anything else, or Thunderbolt enclosures. The idea, make it the smallest possible, and then we can just plug it in anywhere.
And what goes over the PCI bus? What's the goal of the device?
How does it compare to the PCI?
The goal of the device. So a lot of brainstorms so far. The simplest is basically DMA attacks, right? Read and write memory over PCI Express. Because it's got an FPGA that's pretty capable, we can put a soft core on it and actually run an operating system on it, or just bare metal code. Yep. We've also got a spot on it to pop in an SD card, so you can pop in a 1 terabyte micro SD card, and instead of having to tether it over USB to your attack computer, you can pop it in a system and have it dump RAM every half hour, every hour, every day, right? Because it's sitting there and you just go retrieve it later.
All right.
That's pretty cool.
Because it's incredibly similar to something that I was going to build and ask you a bunch of questions about, because I'm not you, and you've basically built the other half of it. So, okay.
Is there any other inputs or outputs besides the SDIO interface and the PCI Express interface?
So we've got one PCB that's going to work for 2 different versions of it. The first version is the basic version, which will be lower feature. It'll be one PCI Express lane, and it'll have USB 2.0 for exfiltrating data. So there'll be a little like connector on it that you can route outside the system to communicate from the other end. The other more advanced one is going to have 2x PCIe, but it actually has 2 PCIe ports, two SerDeses, right? So where it'll be PCI Express on one side and USB 3 on the other side. But because how we've configured it, we can actually just put PCI Express on both sides and make this thing into a very unholy PCI Express bridge. And theoretically, a PCI Express man in the middle with some extra hardware too. So
that's beautiful.
We've got feature
the flexibility.
But yeah, what was that?
The flexibility of it and
the flexibility, like
the USB 3 interface reminds me of the quote unquote riser cards that I've used at work. That are basically USB 3A to USB 3A to extend the PCI Express link. They're the most cursed cables ever, but I mean, high-speed buses.
I sense a very interesting BetterCat module in all of our features.
Yeah, right.
Well, it's funny because there are a couple devices. So Slot Screamer is one that I had worked on years ago, and then Frisk made PCI Leech that used Slot Screamer, and then he found some FPGA-based systems that worked quite a bit better. But you went from having mini PCIe card into this huge full-size PCI Express device with like an add-on card, and I'm excited to go back to smaller boards. There is an M.2 Screamer, which is another one. Apparently, they're very popular in gaming hacks.
Makes sense.
So there are people who, for some reason, want to modify things in memory. So you can never buy these things anywhere because they're all out of stock because everybody buys them to hack and cheat in games or something like that. I don't know.
I've had a lot of fun with the PCI.
I don't know what you're supposed to do with game systems once you've modded them. Like,
well, you get it. I mean, then the game's over, right? Then you have to get a new game system and start playing again.
Says the guy. Like, yeah, okay, we're not gonna talk about that, but of course you say that.
But the PCIe to PCIe bridge thing is cool. Like, yeah, you can do an interposer, like sniff a device if you're evaluating an expansion board. But the first thought I had was like, what happens if you connect the PCIe buses of 2 different computers together?
Interposers are also like $50,000. So,
oh, for sure.
Like actually getting one, bringing that into the lower price range, is something that sounds freaking amazing.
Yeah, there were some very pricey law enforcement versions of these kind of devices years ago, and I'm sure there still are. Cheap ones are better. I mean, it's like the board itself is expensive. We have the first prototype of the PCBs are in fabrication right now, which means we still need to assemble them and we still need to actually do all the gateware, which is going to be a project in and of itself. But the hardware is there. The hardware exists. Just needs some software. Gateware is like software, right?
Yeah. Everyone loves writing Verilog software.
So there's another project, Luna, which is a USB device made by Great Scotch Gadgets, and it's also based on the ECP5 FPGA. Mm-hmm. And so there's going to be some overlap in functionality and features because of the ability to go and take some of that USB stuff and just reuse it. I think there's some work there to get the USB 3 working natively on the Lattice FPGA instead of having to use a separate USB 3 PHY, which would be
amazing.
More space, more hardware, more cost.
So I guess there isn't a USB 3 core on open cores then, huh? I really love the PCI Leech, and I've used it a lot over the years. It's really good for like BitLocker bypasses. As soon as Ulf put the link up, talking about the project, like in the early days, I just ordered one of those chips, like the 8898 or whatever it is. You called it the Slot Screamer?
USB 3380.
Yeah, 3380. Yeah, I have number dyslexia. So I just ordered one of them, and I got the Thunderbolt adapter and the like express card adapter and all that stuff. And I was like set up to do DMA attacks. And you can bypass BitLocker. You can like log into a locked, computer. And what I was asking was, well, it's really exciting that you're making this board because people haven't been able to get the PCI Leech hardware for a long time. And this would sort of, when people are like, oh, I want to get one of those, I can just be like, go buy Joe's board. You don't have to borrow mine. But I was wondering if you'd considered like porting the PCI Leech software to your, to whatever the operating system is you put on there. And because at the core, it's basically just the ability to scan, like you need the trampoline to access high memory. And then it's the ability to scan for kernel signatures in memory and then like patch things at an offset. Right.
Right. So you're basically saying, oh, can we put the logic into the device itself? And yes, absolutely. So I think there are going to be a couple different use cases, though. I think there's going to be that interactive use case that a lot of people are familiar with. There's going to be a forensics-ish use case, which is going to be full-speed memory dumps. One thing that I've noticed about that, though, is, okay, so you've got 4 gigs of memory. You want to dump it. And so you want as many PCI Express lanes as possible, and you want as fast USB as possible to get that off. Well, nobody's compressing that, right? They're just grabbing bytes and shoveling them over those protocols, right? If you compress it, suddenly, your bottleneck is still going to be your PCI Express speed, but you can cram memory down a lot if you wanted to dump it off. Nothing's doing like inline diffing. So if you take a dump once and you pass it off, and then you like get a diff of like what's changed since your last dump, that should be a lot quicker over a narrow channel. So the USB 2, the cheap, Erebus basic USB 2 version should still be able to do some pretty fast memory dumps with all that taken into consideration, because you've got a capable chip on the board itself.
Holy shit. So you're talking about doing like cheat engine stuff on like the whole computer's memory.
Well, I mean, I'm talking about it now because I haven't implemented it yet.
Well, Endel, since it's FPGA, you may, depends on the file you end up implementing, but you may be able to bypass having to have that high memory loader as well. You might be able to use
so it's going to be 64-bit. It's going to be 64-bit.
Oh, 100%.
So, yeah.
Yeah. Nice.
Now what's going to be more of an issue is how Apple and now Microsoft finally have like implemented VTD for protecting against malicious PCI Express devices.
Yep.
The solution to that is you're going to have to be a little more malicious about how you pretend to be a device, right?
Yep.
So the initial bypass of Mac OS's Thunderbolt protections was to pretend to be a Broadcom SD card adapter, because a Broadcom SD card adapter was on the OK list to get its guard dropped. So you just got to figure out what is on the OK list and just be that way.
Or you could potentially write to another memory space, start controlling one of the other devices that's already on them.
Again, if that is enabled on that system.
I mean, as I recall, everyone was super worried about VTD, but as I recall, like all VTD lets you do is mark which devices are internal and which devices are external, right?
You get to throw devices into like a separate memory space. So it's like throwing a page memory address mapped for page walking for memory for a device.
You can create as many groups as there are ACS groups on the system. It's not just two slots, right?
Yeah, as many as you want, or as many as the BIOS has configured the system to support properly.
Yeah.
So I guess the attack from the outside is you have to look like a device that has some kind of legacy properties, or you have to connect to an inside port that is not as locked down.
You have to emulate a USB ISA bridge.
This actually really reminds me of like, you remember back, it was like the early 2000s ish, where like the popular thing for HP and Dell laptops to do was to start whitelisting the like hardware IDs of like mini PCIe Wi-Fi cards. So you'd like go to update your like You'd buy a Wi-Fi, you buy a laptop that had like a janky Broadcom in it. You'd go to put like an Atheros chip in it because you wanted to do some like cool war drivey stuff, and all of a sudden like your machine wouldn't boot, and your BIOS would just tell you, "Oh, thing bad," and you'd have to like bit bang your BIOS to like change the MAC address to like be the right number, and then it would work. Like this sounds like the same thing, which is silly.
And they're also like getting their low end servers and disabling the use of like extended graphics cards because they don't want you to just buy the low end servers. They want you to buy the high end overpriced gaming platform.
Yeah.
Right?
Oh my god, it's FTDI all over again.
But yeah, you know, you're gonna have to get crafty at some point once operating systems start locking stuff down. But whether that means there's going to be a bigger demand for the man in the middle functionality, or whether you're gonna have to do tricky stuff like putting your computer to sleep and swapping your network card out and putting in this card because your network card is trusted, like stuff like that.
I see. So the man in the middle functionality for PCIe would be the killer for that because it's not like they're doing a kind of a Diffie-Hellman key exchange.
Yeah,
between the. Sorry, go ahead.
There have been proposals for authenticating devices, but I don't see any of them as getting implemented anytime soon.
No. Because that requires buy-in from every hardware manufacturer, basically.
That's what PCI Express is buy-in from all the hardware manufacturers. But
yeah, but I mean that'll give you at least 10 years, right? Like,
but you know, PCI Express is buy-in for everyone because it is like the best engineered interface that makes it as easy as possible to get interoperable without effort, right? Whereas any security feature is the exact opposite of that.
Yeah.
Right? Like here, we want to add more features to prevent interoperability and give you reasons why customers are going to call up and complain that their system doesn't work.
It's a surprisingly robust protocol too. I remember seeing somebody stack together like 13 riser cards, like over 2 meters long.
So if you could man in the middle, so if you could man in the middle PCI Express, you basically just wait until you see some other like valid DMA message go by. You can pick out whatever identifier you need from that, and then just generate your own with the same identifier, right?
Yeah, you would sit in between the network card and the PC, right? And you just let everything pass through, and then when you're ready, you just pretend to be the network card and do a DMA request to something that you want, and don't pass to the network card. There's a little bit of messing you have to do with packet ID numbers or whatever, but
yeah.
We can enable the SM bus pins as well. So there's some fun stuff with BMCs and the SM bus these days.
Well, I mean, like the PCI Express spec has JTAG pins on the header as well.
But those are from manufacturer, right?
Well, you know, maybe.
Fair.
it's not well defined. You know, you wouldn't put it past a beginner board designer saying, "Oh, it says JTAG here. I have a JTAG there. Let me wire them up." And accidentally giving JTAG access to every PCI Express device. Like, I mean, I've seen how boards are made. I've seen.
I mean, like, and for some purposes that may be good. Like, it's a common interface. Be easy to do board tests that way.
It's like that all sounds like useful stuff, but I'm still wondering like what would happen if I just use that as a PCIe bridge and just connected two computers together.
So there's a feature called non-transparent bridge, which basically does that. And you basically have a memory window that you can pass stuff between two systems. It's like a cheap interconnect.
Didn't Google like do this for a while?
I mean, like, Intel supports it on a bunch of processors, and it exists.
There's a multi-root. There's SR IOV, which is like IO virtualization for a single root complex, but then there's also multi-root PCIe complexes and multi-root IO virtualization just to add turtles together.
Well, I seem to remember like this is how Google decided to not roll their own hardware, because they basically did and they got it to work, and then it was just too expensive to be their own hardware company and be Google, so they stopped doing it. But like that's what they did. They had PCI, like they stopped using networking aside from a bunch of other stuff that they did where they had like custom boards and custom chips and custom everything. Like they literally stopped using networking cards. They just had PCI to fiber that like the other box was just an address on the PCI bus, and then that was what drove them to drive these giant management systems that are only now starting to get open source like Board.
Holy smokes. So what do you even do with it? Does that just let you put like 16,000 GPUs in one cracking rig, or what? Like,
Well,
what
it
are
lets
they doing with
you-
that?
Well, I mean, I don't know what they're doing with it now, but what they were doing with it is it basically gave them the equivalent of like OpenMP style supercomputing without all the overhead and management of OpenMP. Like you could just do stuff, and instead of basically you'd use code for inter-process communication, and inter-process communication, the other process might be on another machine. Right.
Yeah, the supercomputing magic is not just the CPU, but also the interconnect. And it was just like hey, we've got commodity PCI Express, which is fast, cheap, and low latency, and just use that as the interconnect.
Yep.
Yeah.
Wow. So you could make like an Erebus supercomputer.
Yeah, I'm thinking about like, so like if you like the phones run like Lightning now, right? Or so like if you can run PCI over Lightning.
But-
so if I had a bunch of phones that were just PCI endpoints and I wanted to fuzz a thing,
iPhones have NVMe storage. NVMe is PCI Express. Right.
Oh.
I have a camera with Express card storage. Express card is PCI Express, right? The Xbox and the PlayStation, I don't know PlayStation, Xbox, it uses basically Express card pinout compatible devices, basically NVMe memory cards.
See, this is where I feel like the market for like old iPhones with broken screens that no one wants to fix, that you could just stack in a giant PCI array and like, oh, now I can fuzz iOS programs. How'd that happen?
well, so Express card is either PCI Express or USB, depending on. Basically, it has all of the pins of USB and then all of the pins of PCIe, and then there's a selector pin which says which one they've implemented, and every Express card thing I've seen is either one or the other, but I bet you the storage ones are USB.
So is that like USB 4?
CF Express, Compact Flash Express. So Compact Flash was the old, memory card standard, and Smart Media and Compact Flash were the contenders. Compact Flash was like basically the pinout of card bus, but just in a different form factor.
PCMCIA,
very similar idea. But then they had a SATA version, and now they have a PCI Express version, and that's what Nikon camera uses, and that's what the new Xbox has. So I got a picture somewhere where I got the Xbox memory card and popped it into my camera, and it identified the device. It just
And those cards are using the PCIe circuitry, not USB.
They're using PCI Express. Yeah.
Wow.
Yep. That's how they get such a fast interface. So
it's ridiculously standard these days. So
in the future, is everything going to be PCI Express?
I don't see why not.
Weird.
It's fast. It's cheap. It works. It's proven. Like, when is there ever going to be a case where it makes sense to design something from scratch when you could just use PCI Express?
Yeah, it's just basically serial memory mapping as a protocol. So,
well, they'd better be really confident that VTD is a sufficient security mechanism.
Well, the funny thing is that PCI Express is just a networking protocol, like at its core. It's not even really a bus protocol. It's networking. So it's more like a it's more like IP or ARP or something.
That's deeply trippy. No, so PCI Express. I was just sort of thinking about the physical connections for PCI Express. There's like it can go over Lightning, Thunderbolt, USB 3.
Well, USB-C.
USB-C, sorry, yeah.
Yeah, and USB 4. Thunderbolt, yeah. There is actually a specification for external cabling, but it was never actually really used. So
interesting. So if you had the Erebus set up as a bridge, what would you do for cabling?
So if it were in a bridge and I still was like in an attack mode, right? What it would be is it'd be an M.2 AE connector in the target system, right? And then there'd be a flat flex cable that would come out the back with another PCI lane and that would go into like a dummy card that would adapt it into, PCI Express, which would go into a Thunderbolt enclosure to my laptop or into my laptop directly or something like that.
So just a flat cable.
Flat flex cable, yeah.
Awesome. Wow, that's super wild.
Yeah, I just am seeing that the board's going to get shipped sometime next week, and then we'll get it, and then we'll have to work on it.
So how many revisions of a board do you usually go through? And I'm asking for a friend who has just gone through 4 revisions of a board with each with their own unique stupid errors on them.
It depends. So for Tigard, we had the first revision. So Tigard was there was a prior project, Time P, which was basically the same design. I had talked to the guy who put it together, David Tomaszuk, and he had laid it out. And so for Tigard, we wanted something from scratch with a few different features, but it was the same concept. So like we kind of had a pre-prototype already, and it's a pretty well understood chip, very widely used. And so we still had our revision 1 and our revision 0, which was our like test platform, which pretty much mostly worked. And then we had the almost production ready 0.9, which we actually made a small volume run and still found some issues with. And then we had 1.0, which worked great, and that's what we sold with crowd supply. But I still noticed that there were some issues with the spacing of the connectors, where if you had 2 flat connectors connected at the same time next to each other, there wasn't enough room. So we made a minor adjustment for version 1.1 where we just put a little more space between the connectors. So 4 to 5 board revisions for a simple board that even worked the first time. So I have no idea how many board revisions are going to be for a board that is dealing with 5 gigahertz signals and yeah. So it's got an FPGA. It's got 256 megabytes of RAM. It's got 8 gigabytes of flash. It's got USB 2 and 3. It's got 4 power regulators, voltage regulators. So it's not a simple board.
So what I'm hearing is I'm still in the normal range of normal expected failure. I mean, my friend is in the normal range of normal expected failure. Yeah. So nothing to be ashamed of. That's good to know.
No. Assuming you have something that works, right?
Oh yeah. I've just been I've been making a thing that runs on 18650 batteries. And so when I screw up, I've basically just made a really complicated fire starter. So it's got but it's not vaporizing anything you want to inhale. That's the problem.
Doesn't mean it's not a vape.
Yeah, it's vaporizing something.
Yeah,
that's for sure. Awesome. So let me ask you, you're way farther down the line of like designing and building boards than I am. Actually, I just learned KiCad earlier this year or late last year. And you gave me probably the most useful piece of advice for learning KiCad, which is that what did you say? You have to pretend it's like a mouse with 101 buttons. It's like you never click anything. It's just the keyboard becomes the mouse button.
Mouse over and know which key on the keyboard to press.
Yes, which it's another interface designed by someone that hates people for sure. But once you
I think it's mostly Germans.
I didn't want to get racial with it, but I'm pretty sure that OpenOCD and KiCad were both designed by Germans.
German is not a race.
Well, what is it? I don't know. A species?
A
subspecies? A nationality? Okay.
Oh god.
I don't know. I just got someone got really mad at me for saying that grizzly bears and brown bears were the same species the other day. So now I'm afraid I don't know what words mean at this point.
Yeah, I can echo that sentiment. Like, I don't know jack about jack when it comes to hardware, but like I managed to learn KiCad. Like I know how to make all the lines and the parts and the things, and I know how to like import symbols from random places on the internet. Like,
well, the thing about
just wait until the next major version where they change all of the KiCad.
Oh no, I'm not. I version 5 forever.
Yeah,
I'm not tracking with version 6.
Isn't that what hardware people do? I mean, like the one red team I did where they had like electron microscopes, they were all running on XP.
Yeah, well, that's because
my pick and place machine runs XP.
Yeah, I was going to ask you about the pick and place. So I'm I just got my own reflow oven like about a year ago. So now I can like order the board from Osh Park. I can cut a stencil on my craft cutter. I like, put the solder paste on, and then I have to like tweeze all the components on and stick it in the oven. Right. So I'm kind of up to that part, and I'm pretty comfortable with that. But I wanted to ask you do you have like a personal use pick and place like in your house?
It arrived today.
Oh goodness! So you've just ascended to the next level.
I've just inherited a new project.
Yeah, well, so strangely enough, I've been kind of lurking around the idea. So I've been on this mailing list of people that bought this Chinese pick and place machine from like 2-3 years ago. And I follow that's the one mailing list where I follow the traffic because I'm waiting until it seems like it's safe to go in the water, but it's become like a part to full-time job for most of them, just trying to figure out how to it's kind of like Audrey 2, like they just keep feeding it more and more blood.
So like, do we have an over/under on when China launches an Aurora based on just American hackers, because like they all pick and place their own stuff now, and it's way easier to get firmware in that way?
Well, the first thing you do when you get some equipment from China is you like put an alternate firmware on that's usually written by someone in Germany, right? So at least it's spread around a little bit in terms of the supply side risk.
Yeah.
Or Israeli.
or wherever. Whatever nationality.
You swap one group of spies for another and pray that they don't talk to each other.
Yeah, exactly.
I want them all on there so they can watch each other.
Yeah.
Right? They're not going to use their good stuff if they know each other's watching.
Man. That seems sound. So, okay, so you just got a pick and place machine today. Which one did you get?
I got a Neoden 4.
Oh, so, where's that from?
China. But it's kind of a step above the Charm High tier of desktop ones.
Yeah, the Charm High, that's the mailing list I'm on. That it seems like that one might require a little too much hand-holding for me.
Yeah. And I've been eyeing those for a long time. I've probably been on that mailing list lurking as long as you have. I've never actually I still don't need one. That's the funny thing. But it.
Don't you though?
I mean, what's need got to do with anything?
Exactly. But yeah, the Neoden was the smallest, the biggest, the highest end one that would still fit in my office. Still kind of like a desktop-ish size. It's got 4 heads and a few more feeders, a little more advanced feeders than the Charm High does. And the reason I've got it is because I was procrastinating trying to finish the Applied Physical Attacks 2 class and serving the web and not doing the work I should be doing. And that's kind of how all my projects start. But like I do a lot of like 1-off or 10-off things. And I always avoid small components because I'm so impatient when it comes to assembling them. Like I use a lot of modules, and so like I'll get a module with the microcontroller and a bunch of pinouts and everything, and just because it works. But when I scale that a little bit beyond that, like I'm not sure I'm ready to go and talk to a contract manufacturer to have it done. I definitely am not going to do it myself. I'd really love to have something that just places all my passive components for me, right? So if I have this thing loaded up with all the standard resistors and capacitors I use, and when I design a board, I just have it do all the resistors, capacitors, and I just do the 1 or 2 other chips by myself. Like that's going to save me time, because Now the dilemma is right now you can get JLC PCB and PCBWay. They'll also do like manufacturing like that, where they'll manufacture your PCB and they'll put a bunch of components on it really cheap if you use their standard part library. So I guess I'm kind of implementing that too, but maybe I'm just hedging my bet for like the blockade that's coming across the Pacific Ocean, that we're not going to get stuff anymore, or I'm not going to get my DHL packages from China in 2 days. It's going to be a more realistic week or so.
Well, if that happens, I think electronics in this country is going to be basically over, because where would we even get semiconductors?
That's why I've got a huge box of them, right?
Oh, it's to just stockpile them.
And and the South American semiconductor farm begin.
It's in there. It's in the closet with the Purell and toilet paper.
We're gonna start harvesting them off of old hacker badges.
Maybe that's how
hacker badges.
This one has STM32. Yes.
Maybe that's how we're gonna revitalize the energy sector. We're all gonna make semiconductors now.
Oh man! So I do this thing where
who needs rolls when you got reels?
Right on.
As he holds up a box of reels.
Yeah. So I kind of decided, like, when I started designing boards, I just decided the smallest thing I can comfortably tweeze, onto a board is like a 0805 size, resistor. So I just designed everything around 0805, and I was like, oh, that's great. And like anything will be bigger than that. But I kind of ran into a problem with switching power regulators. So like the buck converters, boost converters, buck boost, a lot of those no longer come in a size that is like manageable by a human, and they don't have like a bigger package available. And that's kind of where I started thinking maybe I should get a robot, because man, it's it's less than 2 millimeters long, and then a little narrower than that, and it's like ball grid array. And what makes it worse is it's like 2 by 3 pins. So there's a right orientation and a wrong orientation, and you can't actually read what's on the top of it without a microscope. Man, so if you drop it and like flip it, you have to like get the microscope out to see which way it landed. It's just a nightmare.
So that's really part of why I don't actually need a pick and place machine, because like I kind of standardized it on a 603s because I did it a few years ago when I could still see them. And I can't really anymore. But the Charm High, the inexpensive desktop one, like it can technically do 0603s. It advertises 0402s, but it doesn't do them great. So that tier of machine is not going to be able to do anything I can't do by hand. It's just going to do it quicker.
And that's kind of what I decided too, because all the people on the list are complaining about how it is not putting things down correctly and needs to be recalibrated all the time. And I'm like, I don't need a robot that can do things worse than me. That sort of defeats the purpose of the robot, right?
I don't need a job as a babysitter.
Yeah,
yeah.
I'd rather use tweezers than sit there as a babysitter
or a robo-sitter.
Yeah,
I just like the idea of picking parts for comfort seems silly to me after like the third thing maybe I learned how to surface mount solder was a Proxmark 3. I just gave up comfort.
Yeah.
Yeah.
Well, so what are you gonna what's gonna be the first victim of your pick and place machine?
I have no idea. My time.
Oh.
Victim?
Your time, yeah.
My time.
I mean, obviously he's going to build a pick and place machine, right? That's how this works. It's like 3D printers.
Exactly.
He's going to get so angry at this pick and place machine, he's going to make another one.
It's like 3D printers, right? You get a 3D printer and then you print a better 3D printer.
Wait, I got dibs though. Like I have a different project idea. So you were doing like a PCIe bus interposer. What would be great is a lower cost SATA bus interposer.
Yeah.
Just throwing that out
SATA
there.
Nick?
Yeah.
Well, the dilemma there is what's the chip you put inside, right?
That's the best name ever, SATA Nick.
A sock, so it's all of them, right?
I think Travis or Sergey Bratis came up with that one.
Okay.
Yeah. Because I know Travis looked years ago for like the SATA controller to make the SATA face dancer, and was unsuccessful in finding anything that would work for that. All the SATA controllers like that you get on drives are like unlisted, unpurchasable parts.
Yep.
Like, so you look at the chips on the drive, Samsung, Marvell, everyone else, like they make them, they don't sell them, they don't list them, they don't have data sheets, nothing.
Yep.
You can find something on open cores and use an FPGA, but then again, you've got another project in addition to your pick and place machine and your PCB mill and your open cores, Verilog implementation of SATA. You still haven't even gotten to the problem you want to do, which is actually have a SATA man in the middle device, right? Like,
Yeah, well, there is one.
Has
There
anyone
is
ever
there
actually
is one.
pulled anything off of open cores that worked? By the way,
I haven't. But
okay.
I heard one time someone took an 8051 core off of there and actually used it for something, but I don't remember any details.
I've got OpenRISC running before on a digital board. So
Nice.
Yeah, so for SATA man in the middle stuff, there's actually a lot of kind of vulnerabilities there that you can kind of get to if you manage to like reverse a disk controller firmware. But it would be, just like it's easier to, spot web bugs from a man in the middle position. It's easier to spot SATA bugs from a man in the middle position, because usually there's like proprietary vendor commands to update the firmware, right? And that would be kind of how you would implement an attack, is like, oh, here's some malware that like then goes and writes itself into your hard drive controller firmware. So good luck with all that. And because kind of the neat thing about that is, up until recently, there was absolutely no way to verify the firmware that was in a hard disk controller, like from the CPU. I heard a rumor that Intel is like threatening to come out with some new spec for like verifiable disks or disk controllers, but I don't know if that's hit the market. I don't know if that's going to be a real thing. But
That'd be great if they did.
Yeah, no, I used to complain about this a lot at a previous job, because there actually have been weaponized disk controller rootkits in the past, and that lets you do fun stuff. Like, it lets you work around some types of full disk encryption, although not the ones that don't actually require the hard drive to do anything, which is most of the modern ones. But it on unencrypted drives, it lets you do fun stuff like anytime somebody like reads a binary from the disk, you could like insert malware in it. And obviously disk malware can hide as much info as it wants because it's got the whole hard drive. And it can control like how much of the hard drive you can actually see. I don't know, there's a lot of neat tricks you can do. But there have been incidences of hard disk malware before. And the key thing is there's these like proprietary vendor commands to update the firmware. And they're usually pretty difficult to track down. But if you had even just a bus sniffer, right? Like not an interposer, you could just run the vendor's disk update command and be like, oh, there's the SATA command that updates the firmware. Like, we'll go with that. And
that's how Western Digital found the China ones, right? The Chinese microcontrollers that were on the hard drives, and it was like a whole bunch of stuff had to get thrown out.
Yep. And like historically, hard disks also haven't done a great job of requiring like cryptographic signatures on their firmware updates. The usual stuff. And the other thing about disk controllers is it's a very narrow market. There's only like 3 suppliers. So there's it's surprising, and they're all ARM based. So it's actually like surprisingly homogeneous. But
yeah, Intel even had ARM disk controllers.
There you go. Hey, Intel made ARMs. Those voting machines had Intel ARMs in them.
Nvidia's going to make ARMs now. Supposedly as a general purpose CPU.
We're just surrounded by ARMs dealers.
In every sense of the word.
Let's say,
is that our joke for the episode?
Well, I think we're above our quota. So. While we're taking a quick break from our conversation with Joe Fitz, I just wanted to let you all know that the next 2 episodes are going to be absolute fire. We have 2 in the can already. I don't want to give anything away, but we have been on a bit of a tear. It's also an exciting time. Our conferences are back. ShmooCon is running right now. It looks like TourCamp is going to happen. Stay tuned for updates about other conferences. But as a reminder, while you're out again at your favorite security conference, you can give us a call. Perhaps you're drinking in the lobby and commiserating with your fellow security professionals about the sad state of global security. why don't you call the hacker helpline and leave us a soundbite? You don't need to identify yourself. Our number is area code 206-486-6272. That's 206-486-NARC. You can also direct message us on Twitter at symbolcrash1. That's SYMBOL crash and the number 1. Or at podcast@symbolcrash.com. Very, very excited that the conferences are back. Many of you have said that this podcast has acted as a bit of a stand-in for missing all the conferences. It's kind of like the sort of conversations that you would have, in the lobby. And I just wanted to let you know that we're not planning on winding down, slowing down, or stopping as a result of perhaps the pandemic coming to an end. We have not yet run out of interesting hackers to interview, and there's no actual end in sight. So with that, we'll return to our phenomenal interview with Joe Fitz, already in progress. Take care. Oh, you mentioned your new class. I forgot to ask you about this earlier. So you were doing all these just to kind of so you were super busy doing training for years and years, and traveling all over the place. You've been at Black Hat how many years in a row?
Several.
Like I don't know, 8 something.
Something
7,
like that. No,
8,
maybe
6, somewhere like that. So when the pandemic started, you're like, oh hey, suddenly I'm not traveling so much. How did you kind of like pivot to? So you're doing like online stuff now, right?
Yeah. So
how does that work?
It's interesting. So when it hit, kind of saw the writing on the wall and didn't expect Black Hat to be happening that year. And so like even before Black Hat made their plans, I'm like, yeah, heads up, I'm not doing 4 separate hardware classes this year. Like even if everything gets better by then, like I'm getting ready to do what I can do remote. So like it was April when I was already thinking about how to do anything remote. So I put off classes 2, 3, and 4 and focused on number 1, which is one I'd done long enough and repeatedly enough that like I could probably actually make it happen. And so part of that was actually kind of comprehending what it meant to actually do a remote class. So when I'm doing a live class, people have a dedicated time to do it. And even when I go on site to companies, like it's funny, as much as they're paying for training, what they're really paying for is the corporate culture acceptable excuse from checking their email constantly for a day or 2 or 3 or 4, right? So like that's what they get. They get to focus on something for a day because training is okay. And so I go and I show up. And I have built the whole class around that, about keeping attention for that 8-hour period multiple days in a row. But when we switch to remote, like it's not going like that. There are classes who will try and like do it like that, but you end up with the worst of both worlds. You end up with the fact that you have to be in the same spot for 8 hours of a real class, as well as the like not understanding what's going on and miscommunication of a remote class. So I basically went straight for the self-paced version, right? I took all the labs that I had, and I used to try and do like a half-hour lecture, 90-minute lab time in my live classes, and I cut that down. So it's 5 to 10 minutes of lecture and then 15 to 20 minutes of lab time, right? So make it into smaller chunks because the reality is people are distracted. They're at home, they're at work, they're, waking up with kids, all sorts of things. And so,
speaking from experience, right?
Yeah, no, what that's like. But yeah, being able to go and work on something and learn something in half an hour is pretty much what needs to happen if you're going to have a sustainable self-paced class. So some people will do the class and they'll do half an hour a day. Some people will do like an hour a week. And it doesn't matter because the sequence of the class is all there. The other thing that benefits is that, when you teach something, you have all these tangents you want to go down and talk about. And I could talk for 3 hours about UART and, UART pinouts. But no one's going to want to hear that. But I can go and I can do my 5-minute lecture on UART pinouts and then do 3 side lectures on esoteric topics about UART pinouts and link them down at the bottom, and people can go and watch them and get that supporting information, but not cloud up the ones that are just having a hard time focusing on the core function, core bits. So that's kind of the difference between an in-person class and a remote class, snipping it into those half-hour chunks with no more than 5 or 10 minutes of lecture at a time, and like hands-on where you actually get something done within a short amount of time. So that's worked. I did Black Hat in 2020. That was the first time I did a remote class. And then after that, I opened it up to like individuals to go to my website and just register. And I ship them a box of hardware, all the tools they need. And they can go and walk through the class with video lectures, followed by labs, followed by video tips and hints, followed by walkthroughs, which has worked pretty well for lots of people. And so kind of let that roll. And then it was very clear that like, okay, 2021 is probably not going to be all that much better than 2020. So maybe I should think about doing another class. So I had been doing a couple remote private trainings where they wanted the 4 days of training. So I had already done this class remotely. I wanted to make that be remote self-paced as well. So my goal was to have it done August 1st, then September 1st, then October 1st, and then November 1st, and then November 2nd, and now November 3rd. And so I finally have it up on my website. You can go and register for class number 2. But yeah, it's been it's amazing how much work it takes to put something like that together, knowing that it's going to be viewed many, many, many times over and over again.
Are you, were you doing remote training before the pandemic, like once in a while?
Nope, never. I wouldn't even really consider it.
So was this all just like a theory you came up with that worked out, or like how did you come by this half-hour increment number? Because it seems actually really insightful.
So when you go and try and look for information about online learning, you dive into this cesspool of sales and marketing. Yes. And you've ever heard of a sales funnel, right?
Oh yes.
Well,
like the Sandler.
We've got sales funnels of sales funneling leading you down the path to buy a sales funnel, so you can have your customers go down your sales funnel and funnel up your sales all over your funnel, right? And it's really disappointing because so there's sales funnels, and then there's corporate mandatory training, right? That's remote training, as I could find really open resources about it. And I don't want to do a sales funnel, right? And I don't want to do crappy corporate training, right? The whole thing about crappy corporate training is like it's mandatory compliance training. You need to go and make a training that's just enough to keep people's attention for long enough that they can check a box in the right spot and get credit for doing like whatever, and certifying that they're not going to touch, bloodborne pathogens, or they're not going to like touch other things they shouldn't, or, whatever, like all these things that people apparently need training to tell them to do that, I don't know, compliance training. But if you look at a lot of the objectives that they put in, like when they tell you how to make your mandatory, Sarbanes-Oxley like compliance training, like they give you all these tips, like do this, put images in, chunks of time, and all those tips actually are relevant to actually teaching useful information, because they're tips about keeping people's interest. And you watch TV, right, and movies, and like you watch a movie from the 80s and 90s, or you watch a movie from today, and it's really different how they're paced, right? And they're paced due to just get people's attention. And I didn't think that I could go any shorter than half an hour and a 5-minute lecture to get enough useful information. So that's where I settled on that. I settled on it because it was the smallest amount of time I could get useful information in a lecture and useful accomplishment in a lab. And that's where it came from. Does that make sense?
So, yeah. I mean, there's some thankless dude somewhere, like maybe did some research or whatever, and then like had the horrible job of writing up like helpful tips to make your Sarbanes-Oxley training more useful or more interesting, like to hold people's attention. And they actually did their homework at some point and then wrote that down. When the truth of the matter is, you might as well just give the fuck up for Sarbanes-Oxley training. But somewhere did a good job, and you like found their notes and like repurposed it to the actual like useful effect. That's kind of nice.
What it reminds me of is there's this Pomodoro method of sort of a task management where it's like you set one of those tomato clocks for 20 minutes, and then you like work for 20 minutes, and then take a small break, like attention break, to something else, check emails or something like that for another 10 minutes, or even if it's just to look at your phone for 10 minutes. But it's like 30 minute mark is about like how long you can keep somebody's attention completely invested without having some sort of a side tangent.
Oh, man, I think I totally misinterpreted that method, because like I do the thing where I like, to get over like procrastination, I'll like set a timer for 10 minutes and be like, I'll just work on it for 10 minutes. And then I trick myself into going into like super hyper focus mode. And then the timer goes off and I like throw it against the wall and I keep working for another 6 hours.
That's like a strategy they give like ADD kids to like do schoolwork, is they tell you to like do it in 10 minutes.
Hey.
But I think at the end of the day,
you're just
like
outing me.
You outed yourself. All you had to do is not say that part. But I think at the end of the day, a lot of this stuff is tribal, and like nobody really has figured it out. I mean, I remember right after the pandemic started, and like the first thing that happened at work is like all of a sudden I got force joined into a Slack room with like maybe 100 people. And it was totally silent for about 20 minutes until somebody came in the room and said, "So you're all probably wondering why you're here. You're all here because at some point on your HR profiles, you've indicated that you've all actually been remote before the rest of us. Nobody knows how to do that here. Figure it out. Teach everyone else. This is your new priority."
Oh, that's pretty cool.
You're like, I mean, to their credit, it worked.
Let me guess. That was a person who didn't know how to do remote.
Yeah.
Yeah.
I mean,
sounds like a nightmare.
Like, you're not wrong, but also it turned out they were totally right. No one else at the entire company knew how to do remote. And like, to much their chagrin, like we laughed and we joked and then like we wrote some docs, but like it kind of worked. Like it actually turned out like between our powers combined of people's random little this one weird tricks that they'd all adopted for working remote for 5-10 years, like it kind of did like make the difference. And I mean, there were like, we do these things where like they have these polls that they take to kind of take the temperature of the company every once in a while. Like, some companies are kind of, good about this. Some companies are bad. Like ours is really aggressive about it. And like, I mean, the data doesn't lie, I suppose. Like people really found this you're acting, little like to-do list helpful.
You're acting like it's more complicated than just swapping the cream out of your coffee for Bailey's. But it's not. It's just that simple.
Well, I think it's a lot of like explanation, like there's a lot of like it's the same advice that's out there if you Google for it, but if you Google for it, that advice comes with no explanation, so people don't really know how to internalize it and operationalize it, right? Like my favorite one that I love that I see, which is terrible advice, I think, is the like always get up and take a shower and put on like work clothes when you go to work, because like that's the way to do it. And like that's for a number of reasons I think that's a horrible idea. But the reason they're actually telling you that, right, is because like, and there's tons of neuroscience to back this up, like you need some kind of mental divider between I'm awake versus I'm at work. It doesn't matter what that divider is. Really, the advice is just find what that is and do it, right? And there's a bunch of little things like that that's like, oh, like if you explain it, people will do this.
Well, so maybe you should make an online training about how to make online training, Joe. You think there's a market for that?
Has crossed my mind. I could set up like a page, and I give you like a teaser, and like you get the first episode, first lecture free, and then I start spamming you email to come down the sales funnel and learn all the secrets of training and online training, and how you too can be as successful. Stay at home, work from home, teach people how to hack hardware trainer.
Well, not hardware specific.
And don't forget Make Millions.
Oh yeah, you gotta make
millions. I was gonna say, this seems like the kind of model where, like, instead of giving a training on it, you just have a consultancy that's like, I will teach you particularly how to make online trainings for a lot of extra zeros.
Yes.
So are you doing this through a platform, or are you just you're I know you're like shipping people a box. Are you hosting the lectures yourself, or are you using some kind of middleware?
So I looked at a lot of the middleware options, and they are all in those two categories: the like sales funnel and the corporate compliance training. And there are others in between that are not too bad, and I probably could have found a platform that I would have liked, and it would have been worth whatever fees there are for those platforms. But I had talked to a few people who are doing similar things and ended up doing WordPress would be with LearnDash, which is a learning management system for WordPress. and then WooCommerce, which is a store for WordPress. And they all three of those work together pretty well. I'm running the risk of running WordPress, but I'm running I think I am better off running WordPress than I am some of these shoddy like corporate oriented services that you pop that service, you're getting 15 corporate clients and all their email addresses, whereas you gotta pop my WordPress server to get my client list, right? So you're always running a risk, and I really appreciated the face-to-face classes where I really didn't even need to know who was in my class, right? I actually had stickers that I put on things. It didn't say like my name is, it said you can call me, because like it doesn't matter what your name is, right? Sometimes people want to be called by their handles, sometimes they want their names, sometimes they show up and they pick a new name, whatever. And so I kind of long for that level of anonymity that we can like have. But at the same time, so I've got that set up. It works pretty well. I post the videos and the stuff on there. It looks pretty good. There haven't been too many complaints about it. I had thought about I had thought about doing like putting it all on a USB drive, but I was a little bit wary of that since this is my business, and putting my whole business on a USB drive that I ship around the world was a little worrisome to me.
Well, so just to plug the site, so the training course is available on
learn.securinghardware.com.
learn.securinghardware.com.
Yep, and you can just click and put in credit card numbers and get hardware showing up at your door and learn how to use it.
That's pretty cool. So what all's in the box?
So there's 2 classes now. The box has tools and targets. The tools are Tigard, we talked about before, BitMagic, we talked about before, multimeter, and a USB microscope, and a few clips and cables and stuff. The targets for the first class, the one target is a Wi-Fi router, which has been opened up and with some modifications made to make it a little easier. There's no soldering needed for the class. Joe Grand covers soldering in his class. I don't need to overlap with that. Also, I feel like there's some people who are scared of soldering, which is entirely fair. I avoid it when I can. I know how to do it. So the fact that you can go through all these classes and do all sorts of hardware stuff without touching solder, I think is something people don't even realize. And it does, beyond this class, you can do that with real devices as well. For the advanced class that just is online now, that one focuses on like a hardware pen testing technique. So there's an additional board you have in there, a little microcontroller board, but then 2 targets. There's an SSD you get to go and open up, examine, black box analysis, make a block diagram, do some threat modeling, and then dump the firmware off of and get JTAG working. And then there's a thermostat that you do the same thing. You start from the beginning, you look at the marketing material that comes with it, do some threat modeling, figure out how it works and how it doesn't work and how to bypass the protections they put in there. Very cool.
I'm wondering if you have any like sort of tips or like tools for people who are like trying to build their hardware lab out. If there's anything that you'd recommend, the sort of like this thing sort of changed how you do hardware.
Honestly, the USB microscope is interesting to me. I've still been using just those handheld magnifiers with the lights in them.
The USB microscopes came out of a class that I was teaching where the light in the room was really bad. That venue it was like a fancy. It was like a wood paneling in the room, but the lights were just really dim. So it was really hard for anybody to see what they're doing. So I'm like, okay, I need some sort of lights in the kit. And I had these little like lenticular like panel magnifiers in there before, but they didn't really work very well. So I got a USB microscope, and it was tiny. It fit in the kits, and it just plugged in over USB, and you open up the webcam software, and you could see great. And it had a really good focus range. And it turned into like the thing that people like, oh man, this is the best part of the whole class. Best tool in the whole class. Nice. They like the hardware stuff too, but
boy, this is going to be one of those podcasts where I like go and buy a bunch of stuff right after.
So, I'll send you one because I ship out a different one that I was able to get in quantity, not the one that I used to use for class, but I have a box of them that I used to.
Oh, look at that. It's a podcast where you're getting free stuff.
Hey, that's never happened
all
before.
of you listeners, I'm talking to you, Ben. So
deal.
But Yeah, so you can also, the other thing is you take a picture and then you can work on a still image, and counting pins on a still image is so much easier than
Yes.
counting moving things in three-dimensional
That's fair.
things. So yeah, that's probably the one addition that I didn't really expect, and once I added it, made all the difference. Otherwise, like the pair of a logic analyzer and an I/O board really works for me. A lot of people ask about the bus pirate. The
Mhm.
bus pirate is this old Swiss Army knife that like it can do anything. That's true, but it doesn't do anything really well.
No.
So I'd rather have a logic analyzer that does logic analyzer really well, and an I/O board that does I/O board really well. And
Yeah.
even though I have two tools, I feel it's a lot more flexible and versatile for a lot more things than just having the bus pirate. So the Tigard and Bitmagic is what I settled on. Again, before the Tigard, I was using Adafruit's breakout board.
I use those. Yeah.
And you know, they work great, but I wanted something that had level shifting built in, as well as the headers already soldered on, so I wouldn't have to solder them before I hand them out to kits.
Yeah, the problem with the Adafruit boards is they just have like anonymous pin headers, so you have to you spend almost all of your time like worrying that your wiring's not right, or bumping a wire off and being like, shit, which pin was that on? And like they're just numbered.
Well, I had
it's a
custom wiring
struggle.
harnesses made for the Adafruit ones, so that they were labeled. So it said TDI and TX and everything else. So like
that's
on
smart.
the heat shrink tubing on the end of the wire said all that stuff. So you
So
don't have to
yeah,
worry about that.
I saw that you have that on for the Tigard.
Yeah, I'd probably
Yeah,
just get a Tigard at this point.
Would you recommend that people like? I mean, I can ask you for myself, I guess. Like, is it a good idea to just get the hardware first if you think this is going to be a road you're going to go down, or is it better to just kind of buy the thing or obtain the thing that is your project and then let that deal at your tools? Because like with software, it's more like I just get the thing and then I find out, oh, I needed this, oh, I need that. But that's because you can just download stuff, right?
So-
But with hardware, it's a lot like
no matter what, for hardware, you're always going to need a multimeter, you're always going to need a logic analyzer, and you're always going to need an I/O board. Like that's kind of a minimum. So like there's other esoteric stuff you might need to bring in, but the I/O board is like it's a serial adapter, it's a JTAG dongle, it's an SPI adapter, it's an I2C dongle. I'm just alternating dongle and adapter for no particular reason. But the logic analyzer is so you mentioned the bit was it Bitmagic?
Yeah.
The Bitmagic's your logic analyzer, right?
So I used to use the Saley logic analyzer.
I love the Saley. I'm a Saley
they
snob.
have pretty software, and what's great about the Saley is I could put that in front of someone who's never used a logic analyzer, and they could figure it out.
Yeah.
The downside of the Saley is that they discontinued the Logic 4, which was their low-cost one. And I think the low-cost one, it's bad for them because I tell people to go get the 4, but look at the 8 because it's a little bit more, but you can get more. And it was a good upsell, right? Yeah. But they discontinued the 4 and they increased the price on the 8, and now it's $400. So their cheapest product is $400, which is just, I mean, that's more than everything else in the kit combined.
So I love Saley, and I have one of the original 4s. I also have one of the newer ones because they work with much higher speeds. I mean, they are more expensive, but they're much higher speed. But you can get Saley clones from China for like $7. That'll work with their software if you kind of flip some bits here and there. But
so the Bitmagic is actually the same design as the Saley clones, which is the same design as the Saley 8, which is the same design as the USB, and like several other this is there's a Cypress application note about designing a logic analyzer using their chip. Right, so they're all clones of each other. But PulseView is a very highly German influenced user interface to SIGROC, which is a very highly German influenced logic analyzer software package, which is all open source, which is great. And it was actually October 2018, which is when it hit the feature parity I needed for my classes, and that's when I was like, okay, that's it, I'm switching. Nice. And so when I had the opportunity to go refactor and I was rewriting all these labs, that's when I'm like, I need to go full in on the logic analyzer. So I used Bitmagic because it's inexpensive. It's a little much higher build quality than the $7 clones you'll find. But you could use either one. But yeah, it works.
Yeah, so someone just showed me PulseView like a couple months ago, and it really is it is very similar to the Saley interface. But I think it's like the fact that it's open source and you don't actually have to like pirate software to use it with the inexpensive Cypress board is pretty nice.
And when you use PulseView's protocol analyzers,
yes,
when you see those the first time, you're like, oh my gosh, like why was I wasting my time with Saley? Like they're beautiful, they're color coded, they're visual, they're easy to read. Whereas Saley, I think their newest software is a little better, but it was like tiny white text on a light blue background that you couldn't scale, and it's just like
it's hilarious because open source software is like never known for having better UI.
Yeah. So
on a long enough timeline, it'll get better, right?
Yeah. PulseView's protocol analyzers are beautiful, and they're part of the reason why it's my first choice for anything at this point.
I imagine they would be much more expensive. I mean, that's one of the things that I never understood why there's just so many competing like closed source versions, even when like the companies themselves seem like they're sort of supporting the open source community. It's like if you use the open source software and get that working with your and like extend it to work with your software, you never have to support it again. You never have to support the software, and the number of signals and protocols that you'll be able to decode is going to just skyrocket.
So I wonder if I can use my actual Saley hardware with the PulseView software. I should give that a shot.
You can use the original one, but not the newer ones.
Yeah,
fair enough.
Bought a Digilant logic analyzer, and I was like, I just sort of expected it to work with the open source software.
Okay,
and it does not.
So we got the basic kit. The logic analyzer. You got Bitmagic. Everybody needs a multimeter for at least identifying ground pins. And then you've got the USB microscope, which is a new tip for me. That's cool. And the IO board, the Tigard, which is that used to be like you used to need like $3,000 worth of separate dongles to do all that crap. But through the magic of the FT232 or 2232 or whatever you're using, you can just get by with one chip now, which is super nice. Is there anything outside of that that you'd recommend for beginners, like any other tool tips?
So yeah, the core is the multimeter, logic analyzer, and IO board, right? When you've got that, you can do 90% of what you're going to need to do. The USB microscope is a good addition. And then the question earlier was like, well, do I get the hardware first, or do I get the tools first? Well, once you've got those three, then go and get a target and start messing with it and decide what it is you need. Because the next thing you're going to want to get...
And then just real quick, in that vein, my follow-up question, and this seems like just too good of a segue of it, but I totally encourage you to finish that answer, is are there targets that you would encourage people to avoid? Because I know like one of the things I run into with a lot of people asking me about binary exploitation is they go like, oh, I'm going to hack World of Warcraft. And I'm like, okay, so I'm not going to tell you no, but like, I don't want you to get disappointed 10 minutes in.
There's a book on that you should read first.
Exactly.
The next thing you're going to end up needing is a protocol specific adapter. So you're going to find a device that whatever uses its own, JTAG software and hardware, and it's just going to be worth it to buy the vendor's device for that, because if you're going to do a lot of work with it, just do it. Like it'll, it's worth $50 to get a piece of hardware that's going to save you 5 hours, right? The other thing that I would add is a microcontroller board. And that doesn't have to be anything fancy, like a little $5 Arduino Pro Micro is all it takes to go and bit bang a few protocols that like your IO board can't speak, or to do like JTAG searching, JTAGulator style, just a little bit rougher around the edges.
Is a protocol like the debug, the in-circuit debug protocol for some of the really tiny chips, some of the tiny Arduinos? There isn't really a good dongle for, but you can bit bang it with an Arduino really easily.
Tigard does it.
I stand corrected.
Tigard's got a little switch on it. You switch the JTAG SWD switch over to SWD, and you're in SWD mode.
Nice.
That is okay. I got to get me one of those.
And SWD is a very painful protocol if you just want to try and implement it on your own.
It is
much like JTAG itself if you are not using the tools provided.
There is an Arduino sketch that does it though. Like you can just drop in.
Yeah.
But yeah, microcontroller board is really handy to get those protocols that either you don't recognize, don't know, or if you want to do something like one of the labs I have you do is you basically intercept a UART transmission, right? And the microcontroller reads a byte in, checks it. If it's a certain packet, it goes and modifies it. Otherwise, it passes it along, right?
Ooh.
And you can do that in a few lines of C code on an Arduino board that costs $5 and plug it inline in a system powered by the system. And it's a standalone hardware implant. And that's one of the labs in that later class.
Wow.
Nice.
So
yeah, like
that's super
targets.
cool.
Is there a way to like figure out if a target is like I shouldn't go after that because that's going to be too hard?
Well, I usually tell people to go in the Goodwill and buy the bigger DSL modems or the bigger cable modems, like because that means they're the old ones, the bigger old
modems.
Ones. Yeah,
they're bigger. They're easier to see. They're easier to clip onto. They're cheaper. You're gonna break stuff. That's another thing is like buy multiple because you're gonna break it. And if you're not breaking hardware, you're not trying hard enough.
we used to say one must die.
Yeah.
Right.
So,
if we were doing a hardware security assessment, we'd be like, we need at least 2. And then if they were like, sure, no problem, we'd be like, can we get 3?
When someone hands you the cheesy like encrypted USB drive that has their Bitcoin wallet on it, right? You don't break that. But you get a bunch of similar ones and you break them. And when you know how to break them, then you can learn how to not break them. And when you know how to not break them, then you can touch the one that you can't break.
Yep.
Right?
Yeah.
So it's like falling off a bike, right? You learn how to do it. So expect to break stuff. Don't worry about it. You're going to break it and then figure out why you broke it and don't do it again.
And I think for a target like that you'd want to avoid initially might be you more specifically want to target a consumer grade hardware, I think, as opposed to industrial maybe.
Well, industrial is typically easier than consumer.
Yeah, that's a fair point. Yeah,
because you were talking about things that are still running Windows XP.
No phones, no game consoles.
No phones, no game consoles. Yeah.
Well, unless it's a PlayStation, right? PlayStation's no problem.
Well, nothing where there's already a dedicated community of people that are reverse engineering it for profit, right? Like, what's the car thing? Like ECSs? Probably not a good first target.
Well, I usually tell people to before you hack anything, Google it.
Yeah.
Right. Yeah. Just Google whatever the thing is and the word hack and see how far everyone else has gotten. Right.
Yeah.
And because it's usually very, I mean, it can be interesting to like reproduce other people's work. But I think it is a mistake to like launch in on a new hacking project and decide that you're going to do everything yourself without looking at the internet. Because you're basically going to spin your wheels on, trying to identify some chip that like doesn't do anything useful, for 3 days.
Because that's basically what I'm thinking of is like the roadblocks, right? Because like one of my lingering projects has been like there's a lot of IoT based like security camera stuff that's been coming out recently, and a lot of that stuff is like tied to the vendor through like the controller system, and like without going into details because you're all smart people, like it doesn't need to be, right? And it's like, okay, on the one hand, like that tech seems simple enough that the manufacturer probably wants to make it really cheap, and so it's probably not like a phone, right? I probably don't need to decap chips to figure out how that thing works and smash it and just like swap out firmware and have like a running like open source project of like buy all the good cameras, then nuke all the firmware and put your own on there and don't have to, pay 4 times the price for an IP camera. Or maybe they're all ASICs and I'm wasting my time, right? It's like, you don't know until you get one.
Yeah, that's true. Well, I got to say, I've been noticing that a lot more embedded devices are Android based these days. And that's actually really fun because basically you just need to get a serial connection to it or a USB connection to it and then figure out how to enable debugging. And then you can use like the Android debugger and like hack it Android style. And the best, and granted, there are phones that use Android and they're going to be harder targets. They might be more locked down, some of them, right? But there's just random devices that have no threat model at all and literally don't really care. Like, for example, I found this projector that I found.
There's a whole community that I'm part of on Discord that propped up over the last month that is nothing but people
people hacking on this
mutual acquaintance
projector.
of ours buying projectors, and the channel is called Serial Killer.
Yeah,
all they're doing is serial attacks and dropping ADB and getting Android consoles.
There's no need to attack it, man. Like I got one of those projectors because I am in that channel, and I was like, that looks fun, so I ordered one of those. And it shows up. It's a pretty nice projector, and you pop the top off it, and the serial pins are just labeled. I was like, well, there's TX, there's RX. Sweet. We'll just connect the serial cable. You open a console, boom, root shell, right? So, and then you're like, oh, ADB's enabled, right? You could just connect to it with Visor and see what it thinks its UI is supposed to look like, right? And then they have no threat model. Like, they don't really care if people hack it. In fact, if they knew we were doing this, they would probably add that to their their advertising, like, it's totally hackable, like have fun, right? They don't care. There's no vendor lock-in software on a projector. Like, it's just like, they have no reason to keep people off it. But this is the second device I've seen in a month that was Android based and in a kind of surprising way.
An indicator of like a device that is like worth looking at from a hardware perspective is one that is cost optimized, but not too cost optimized, right? So you want something cost optimized, meaning it uses off the shelf components. It just copies a manufacturer's reference design and throws a couple of components on there, and maybe has shoddy software, maybe not, maybe it uses like OEM software. Versus too cost optimized, which is a thing where they actually designed it for mass market and integrated everything and actually custom made everything, right?
I have an example.
But not too cheap.
Yeah, I have an example of a too cost optimized thing. You go into a Walgreens and you see those little handheld console things for $10 that are like a handheld Nintendo, and they come with like 30 or 40 games in them.
Yep.
The black blob of
yeah, exactly.
NES on a chip.
NES on a chip. Someone made an ASIC that's a NES on a chip. And they make these little consoles, and I got really excited because I was like, I can open it up, I can like get in the flash, I can put my own ROMs on there, I can play Mario Brothers or like some actual ROM like on a thing I got for $10. I was super excited. I opened it up. There's nothing on the board but a single blob of black epoxy. Right? And then the wires up to the buttons and the battery, right? that is actually a fabrication technique that is so cost optimized. Yes, the thing is an ASIC. They've put the whole thing in one chip, right? But they didn't even bother to purchase packaging material for the chip. They just produced the raw chip, soldered it down to a board, and then covered the whole thing with that black goo that you can't take off without destroying the chip underneath.
Yeah, it's the NES was like what, a 6502 or something like that, and so somebody has a project to literally recreate a 6502 on a breadboard.
I've seen so much black goo.
Yeah, I hate that black goo. Hey, you got any tips for removing the black goo? It's okay if you don't. No. Yeah, just throw that out there. Hey, okay, so we were talking about.
I've got solvents for that.
Oh yeah, really? Will they melt the bones out of my hand?
Yeah.
Yeah, let's not talk about that.
yeah, it's one of those chemicals.
Yeah, no,
it's not Chef. It's brake cleaner and a couple other things.
If people are interested, you can look up the Things I Won't Work With blog or whatever.
It's not on that list.
I don't want to get into these types of lawsuits. I don't want people sending me pictures of like boneless fingers. Like,
there is fluorine. There is some fluorine, but it's not.
I was going to ask.
It's not an acid.
It's only a little fluorine.
I was going to ask: is it more or less dangerous than hydrazine?
Less dangerous than hydrazine.
Well, that's a low bar. Hey, so okay, we were talking about like how to find an easy target, which sounds real creepy when I phrase it like that. But I am interested. So all like the reason we're telling people not to go for newer boards is because on newer boards, everything is tiny and unlabeled, right? Mm-hmm. And so I have kind of shaky hands to start with. And we kind of were mentioning the PC byte probes and stuff like that earlier, but I'm wondering if you have any tips for connecting probes to kind of the newer boards where like, I've tried to solder mirror wire to these really small pads. But if you screw up at all, you basically lift a trace.
Magnet wire.
What?
Magnet wire.
What did I say? Mirror wire?
Yeah.
Yeah. No, that's for hanging mirrors. That's much thicker. No, yes. Magnet wire. My bad.
Okay, cool.
Yeah. Magnet wire. No, if I was soldering mirror wire to things, that'd be insane. Yes.
So I try not to solder So yeah, the like, oh, there's a thing. I'm gonna put a probe on it, right? That's great for doing it one time, right? But I'm gonna need to connect to this spot a few times. So I want to solder a wire onto it, right? And the next he says like, oh, well, if I solder the wire onto it and I accidentally tug it, I'm gonna like peel it out, right?
Yep.
So I'll put some hot glue over it. Like that's the next step people do.
Oh yeah, I've done that.
You know, that's fine, but like then there's hot glue everywhere, and it's just annoying. So one approach is I get a strip of 0.1 inch headers, and I glue that to the edge of the board, right? And then I use magnet wire from the test point to that 0.1 inch header, and I just like populate all of those pins of that header. You get it?
Oh yeah, that's smart.
You know, like,
nice.
oh, okay, I'm gonna probably need about 10 test points on this, so I get 10 0.1 inch headers in a row, glue them down, and then just solder wires to the ones as I need them. Then I have a header that I can stick onto. I don't have to put any tension on the solder pad itself.
That is so smart.
If I'm going to use it across different devices, though, I go straight to a jig, right? Where I measure its location and I drill a PCB and use a pogo pin.
Ah.
So.
Man, I wish you'd told me about that header thing like years ago.
Yeah, I was like, I could have used that when I first met you.
You have no idea how many times I've like soldered a mirror wire. Damn it, I did it again. A magnet wire into some like tiny little pad, and then glued it down, and then like tripped over a wire or something like a while later, and just like ripped all the traces off the board.
Yeah.
There's a class that I don't teach very often, which is the physical tax on x86 class. And one of the targets is a Windows tablet, and it is the cheapest Windows tablet at the time that you could get. You could get them from Micro Center. It's the one that you go to Micro Center and you're like, oh, there's a Windows tablet for under $100, and I'll buy it. And you buy it, and then you realize it sucks, so you go and you return it, and you're like, oh, for only $50 more, you can get one that doesn't suck. And so, they always had tons of these, like in open box. So you just go in and you buy 30 of them. Which is how I got them from my class. But what we had to do is, I have people poke around on this to find the SPI pins, to find the firmware, to dump the BIOS off there by hardware. I2C is how the touchscreen controller was connected, and a few other interfaces in there. But the problem is, when you poke around inside a device that has a battery, like it's really hard. Like you can't turn power off, right? The battery is literally soldered in. Right. And so I was worried like everything's just going to break because people are going to like be shaky with their hands and poke in the wrong spot. So what I did is all of them we repaired with magnet wire. We soldered to the points and we put it all to a row of headers on the edge. And then we cut a notch out of the back panel so we could snap these things back together. And you had a tablet that was closed with a row of pins coming out the bottom side. And that row of pins was UART, SPI, and I2C connected inside the board. Right. And it worked great. Like I used those tablets over and over again, and very few of them died.
Wow, that is. I think the version of the class that I actually went to, we used those tablets. I vaguely remember something about this, but that is a really good trick. So I wasn't totally far off with the magnet wire anyway. But
yeah. I mean, just the peeling up traces with magnet wire, though. Everyone's been
it hurts. It's a certain kind of trauma.
For like two days at work, I was trying to get these DuPont headers. I was like, because like crimping DuPont headers is like the most annoying thing in the world. So I was just gonna cut the cables in half and solder them to the test points that I needed. Because it was actually broken out. Like, so I was soldering it, and the wires themselves would just not take any solder at all. I think they were aluminum wires or something, but I've never experienced this. This is the most frustrating wires in the world, and I literally wasted like a day and a half just trying to solder this over and over, and like going and cleaning up all the solder. Like,
I've had that. I've had that
for tinning wires.
solder pot
is well worth it. So instead of a soldering iron and a strip of solder, you get a little pot like a crucible, and you put like half pound of solder in it, and you can put all your solder scraps in there too.
Nice.
And it just melts, and so you have this bubbling pot of metal, and you just dip the end of the wire in, and it tins the wire so it has solder on it, and it's so much easier to go and solder it in place then.
Oh.
Is it good for tinning the soldering iron too?
Yeah, I've never had much of a problem with the tinning. I have a tip tinner that I use as well. But
Okay.
Yeah. Same.
Yeah.
Same deal.
Nice.
And also a trick I've seen, I haven't tried it, is you get those ribbon cables, and let's say you have to solder like a whole bunch of pins, and you have a ribbon cable that's the right pitch, but you want to strip it. Well, it's really hard to strip 20 wires all together. Put them on a laser cutter though, and the laser cutter will cut right through the sheet, but not the metal.
Nice.
And then you just slide that end off, and then you have all your wires lined up just the right pitch.
Oh, that's pretty amazing.
I've seen like some super crazy pictures of people using like modified circuit jigs. Like basically they open the back of like a DVD burner and put you put funky firmware on it, and it turns the laser from the burner into kind of like a de-etcher, and they just run over chips, and it totally just takes the enamel off perfectly.
Well, so I did that for obscuring chips. I've got a 5-watt laser on top of a CNC machine.
Yeah.
So to hide the chips, so it makes it harder for class. So
Nice.
Yeah.
Nice.
It just stinks a lot.
Yeah.
I just thought it was cool that like you didn't need some crazy expensive laser. It was like DVD burner and some pirate firmware, yo.
Yeah, that's pretty awesome. You can get the etching CNC rigs for like $20 online these days to do.
But you have to. I actually got one of those for etching boards just to give it a shot. I got one of the Chinese ones. It was very inexpensive, but it shows up with absolutely no safety features. Like it doesn't have. I mean, also the reflow oven did too, but the CNC etcher, it was a bit scary because it's basically a drill bit on an XY table, and it didn't come with limit switches. Right?
Yeah, the $20 one doesn't even have a motor on it. It's just for UV etching.
Oh, I see.
It's pretty slick though. It's just like a pair of sticks. But yeah, oh no, those things don't have safety features.
So have you gotten into decapping at all, or is that kind of not your thing?
Nah, not for a lack of desire, but for a lack of time. So
yeah, it does seem time consuming.
Decapping always seems like that thing that like if you don't actually have an EE, it's just not a thing. Because it's like I have never like the one thing I've always found it difficult to learn is like I can read enough anarchist cookbook style bullshit to like pour noxious chemicals I shouldn't have on top of wafers and do stuff all day long, but like all that so I can get to ultimately a grid that I can't read, right? It's like there's no key of like this line plus this line is like this kind of circuit. Like you have to just know what that stuff is at some point.
Well, Joe, you were saying that was your history though. That was what you did over at Intel.
Yeah, so I was actually in a tools group. So we were writing software to interface to the debug features built into the chips that would run on the testers that would connect to the pins and let them go and do the debug.
Gotcha. Oh, that's awesome.
But in that lab, like we had the infrared emissions machines, we had the laser assisted device alteration. So like you shoot a laser and see if it fails, and that's where your bug is.
Yep.
Yeah, so all sorts of neat stuff that like what's really people say like, oh, chips are getting smaller. Someday all these decapping attacks are going to stop working. That's false, because the chips would not work in the first place if we didn't have all these inspection tools, right? Like you never have a saleable yield of silicon unless you have the tools to do the failure analysis of the ones you manufacture. And those are the exact same tools you're going to use for the reverse engineering as well.
Yeah, I mean, they are sort of prohibitively expensive. But
well, that's if you have them full time, or you have the current model, or all that stuff.
Yeah. There are like third-party failure analysis labs in various places around. So you always have the option of renting time,
and especially in close proximity to silicon manufacturers.
Yep.
Turns out those machines are really expensive to ship.
Yeah,
So they usually don't make it far off the lot.
And actually, there's so few of them that the people that go around and do the regular calibration, like they are familiar with the individual machines, and they'll give them nicknames, and they'll like talk shit about specific machines behind their back sometimes if they're like trouble. You know?
Those are the people who walk around with test equipment running Windows XP embedded, and they go to AMD and they plug it in and they calibrate the AMD machine and they hook up to the network, and then they go to Intel and they connect to the Intel machine and they're on the network, and then they walk to like every other silicon manufacturer with their test equipment running Windows XP on the network.
Joe has adopted the maximum supervillain pose right now. He's literally stroking his beard.
Yeah. The freaking what's that called? The vibration dampening support. Each one, there's like 4 of them, individual device connected over Ethernet. Makes no sense.
Yeah, it's so we were talking about like how industrial equipment is maybe not the hardest target. Yeah, it's true. Hey, you were speaking of which, like you were messing around with SCADA at one point.
That was a while ago, yeah, but I borrowed your PLCs.
Yeah, that's right.
Did I give them back? I think so.
Oh yeah, no, I got them back. I've been afraid to plug it back into my nuke plant because I don't know what kind of weird implants are in there.
Yeah, actually, that was interesting because that's when I actually made my first hardware implant before hardware implants were a thing. And then like suddenly this ant catalog came out, like, oh, so people are really doing this. Cool. But yeah, like you open the thing up and it's
nearly enough.
It's over the shelf parts, right? And there's no obfuscation of anything. There's no tamper evident anything, right? You just literally open the thing up, pop it open. I was able to stuff an Arduino and a wireless module inside, solder it onto the board, close the thing back up. Even with the case off, you couldn't see it was there. There were so many boards already in there. But yeah, like, so it was a Siemens S7 1200, I think it was. PLC.
Yup. Which is running at a bunch of like power plants, chemical plants, water control stuff. That's a very widespread,
very common one.
Yeah.
Well, and it's interesting because a lot of them are fine. Like, if you are in one of those facilities, that's great. But if you have a remote station that's monitoring water levels downstream from your hydroelectric plant, and you don't consider the fact that this thing is readily tamperable, then you've got a problem, right? Or if, you have this plant that's running for 20 years, and then, of course, you want to check Facebook on the PLC controller, then you put it on the internet. Like, it's the same story over and over again. Everything's fine until you put it on the internet.
Yeah, they talk a lot about air gaps in the power industry, though. They're familiar with the concept of air gap. I heard a lot of people say like air gap is life, like it was like a slogan. They'd shout it, air gap is life.
And then somehow those would still be on the internet. I'd be like, where air gap?
Well, no, it's not air gap, meaning it doesn't use wireless. We just put a wire.
That's just the story of all air gaps, is how no one in the entire universe apparently knows what an air gap is.
Well, I knew that the term was starting to get overloaded when I was working at a cloud company, and they started talking about their like their air gapped cloud. And I was like, I think there's been a fundamental misunderstanding. Like they're like, yeah, it's like there's like 2 clouds and there's an air gap between them, and it was like, okay,
I'm laughing or crying right now.
I don't think that means
I hear a lot about are data diodes.
Oh, yeah, I was just gonna say that one.
And this is,
that's actually a real thing.
I know, that's what makes me laugh.
So what they do, basically, they have like a logging requirement. I'm not sure if this is what you mean by data diode, but this is actually a common trick in some of these networks where they're trying to make an air gap, right? Mm-hmm. So they have a logging requirement from like the secure, control network out to the rest of, the corp network or whatever, or like to where the logging server is. And what they would do is they would take like an Ethernet cable and they would cut one of the pairs, right? They would cut the receive pair entirely so that you could only send data in one direction on this cable. And then they would switch to using syslog over UDP. And they would just like cram all their logs through a one-way Ethernet cable over UDP so they didn't have to do a bidirectional handshake to start it off. And I actually always thought that was kind of a neat trick. But, you know, it is a little messy.
Yeah, how many of those are actually cables that only have two pairs attached?
Well, yeah, I mean,
how
so
many
that's
of them are plugged into more advanced network adapters that have auto direction and auto.
But
they didn't at the time, and so they tested it, and then they upgraded the network adapter, and suddenly it's not a data diode anymore, but it still works, so they don't notice.
Yeah,
it works in one way, but they didn't test that it doesn't work in the other way.
Yeah, I imagine that's happened.
The other thing, so you know, they have like it's air gapped, so no USB drives are allowed in. That's fair, right? But then all this software requires dongles, like application dongles and license dongles, and they don't want to like have these walking around. So what they do is they get like a dongle server, right? So it's basically a USB sharing server that they connect to the network to their air-gapped machines, right? And this thing is like a crappy like embedded system with 1 USB port and a hub. It's a Raspberry Pi, right, with a hub, right, running Linux 2.4, and like some shoddy like USB over IP protocol with some custom drivers on the Windows XP system on the other end.
It's Stuxnet as a service.
And yeah.
So, USB over IP over ISDN. Yay.
So you show up with your
ATM frames.
You show up with your malicious dongle, you plug it in this thing, you pop the USB server, and then you have a like direct connection to all these device drivers running on all the systems, you know, on the network that are all air gapped. Like,
I mean, what's great about that is like you don't need to even put your persistence on the system. You could just put your persistence on the USB dropper thing and have that. It's like,
well, like have it show up as a HID device.
Yeah.
Oh man. Good stuff. So, bit of a topic change. So there's one other thing I wanted to run by you. We may have to edit this out. But I was wondering if you've been following the work of the guy who's been dumping the Intel microcode out.
I have, and you know, not very closely, but I keep an eye on it. It's pretty interesting to see all the stuff that's being pulled out. None of it is really surprising to me, though.
Yeah,
you know, it on the one hand, like. I'm excited to see all the work that's happening and like all the proof that like some things that I thought were issues and were dismissed as non-issues a decade ago are turning out to be issues. On the other hand, it's a little frustrating because like he talks so much about his progress that like there's always something new, but like, oh wait, what's new this time? So
yeah.
But yeah, persistence. Oh my gosh, persistence. I have no ability to ever come close to, so it's pretty impressive in that regard. Yeah, and it's all baby steps, right? You know, you get your foothold into the manageability engine, you get your foothold into the microcode. You know, you take enough time, you reverse the microcode. So nothing that's going on is impossible. It's all difficult, and it all takes a lot of time and knowledge, but like. I just wonder. He's focusing mostly on like one of the Atom cores, which, as opposed to the big core, like the ones in the desktop server CPUs. So I'm curious whether there's more work that's not being published, or whether other people are following along on their hardware at home or at their place of work.
Absolutely wondering how much like overlap there is between the Atom, I think it's Goldmont CPUs, and the Haswells and etc. and sort of like the Well line onwards.
I saw one other dude who wrote some kind of more general purpose assembly that was using it was using a side channel through like it was like the instruction counter or something, the number of operations. There was some register that counted the number of operations that had happened. And he basically constantly queries that to see how many operations had happened, and then like runs different instructions and makes inferences about differences in the number of actual microcode instructions that have executed when he like ran a certain bit of assembly. So he's basically using there's a microcode instruction counter, and he's using it as a side channel to basically kind of specter out what the actual microcode is. And I thought that was pretty interesting.
That's pretty impressive.
Yeah, I don't know if that's been sort of made general purpose yet, but yeah, it's definitely. I actually that's another one where I saw the guy's first blog post, and he's like, I'm targeting this specific hardware, and you can follow along at home. So I went out and got that exact chip. I have exactly the same debug cable he has and the same unit. But then I put it on a shelf and I haven't been back to it. So in the event I actually run out of other stuff to work on, I might have a swing at it. But just sort of reproducing the steps, because like sometimes it's valuable just to like absolutely mimic what someone else did.
I mean, when it gets to a certain point too, you could also potentially turn the CPU into a RISC-V machine.
Awesome.
That might be a bit risky though. So.
Yeah, it's certainly risky business.
Yeah, I hear risk is good.
Well, it was absolutely required for that one Mission Impossible movie, right? It's got a RISC processor. It's really impressive. And now everything's switching to ARM. I guess the future is nothing but RISC. Dead air. Dead air. Okay.
Not because it's not funny, only because it's true.
Everyone's like, yes, the future is nothing but RISC.
Yeah, basically.
Yeah. Well, I feel like the general blood sugar is dropping. So does anyone have any let's move towards wrapping up, I guess. Does anyone have any other questions they didn't get a chance to ask? Or Joe, do you have anything else you'd like to plug? You haven't plugged yet?
Yeah, B-Sides, Portland.
We didn't talk about the hackerspace stuff. So,
and if you're in the Portland area, there's a hackerspace. So once things are back to normal, come visit the hackerspace.
So let's get into the hackerspace stuff a little bit before we go. Yeah. So what's the name of your hackerspace in Portland there?
It's Control H or PDX Hackerspace. Goes by both names. It's in North Portland. It's kind of a commercial building that was a bit run down, and we kind of rehabilitated, or John and Melinda basically did all the work to rehabilitate it. And now we've got a nice big area that, in the normal times is often used as a co-working space. There's a craft lab, laser cutter, a whole wood shop, electronics lab with PCB mill, soldering stations, the whole bit.
Nice.
I'm the one with the PNP machine, but maybe this will end up there once it has outlived its usefulness or takes up too much space in my office.
So is the space mostly hardware focused?
I guess so.
Yeah.
It's definitely a hacker space and a maker space. There's a lot of members who are all about making things and really not at all involved in InfoSec at all. I know there's some hacker spaces that are like totally into the InfoSec side of things, that end of hacking. But yeah, a lot of craft, a lot of woodworking, all going on there.
Oh, that's awesome.
So is that I know that Osh Park, the company I have all my boards made at, got spun off of some Portland hackerspace. Was this it, or was that a different one?
That's Dorkbot. Dorkbot is a informal group of, I believe it's people doing weird things with electricity.
Yeah, I used to go to Dorkbot Seattle. So that came out of Dorkbot Portland?
Dorkbot Portland, which recently has had their meetings at Control H. So
Oh.
or their gatherings. There a lot of overlap in different groups. So.
Very cool. Thanks for clearing that up. And then, so how long have you been involved in B-Sides Portland?
Besides Portland was the first InfoSec conference I was ever at, and it was the first one I ever spoke at. Its first couple years, but then about 5 or 6 years ago, the old crew was kind of getting worn out, and we had a date and we had a CFP open, but we didn't have a venue or any other plans. And training was a little slow in those days, so I had time, so I found a venue and like, oh great, Joe, keep going. They're like, what? And I'm like, well, you got the venue, you can do the other stuff too. I'm like, okay. And I ended up with it on my lap, and that was fine. And it evolved that was when B-Sides Portland was 100 to 150 people. The last in-person one we had, I think we hit 1,000 registrations. Turned into a very different kind of event over the course of 5 years. But multi-track, multi-day, very local focused, free admission conference.
Holy smokes.
I didn't realize it was free admission.
Well, it's pay what you want. So, you can register for free and there's room for you. But
so
the more money you give, the more stuff comes in your swag bag.
So you either pay in money or guilt.
Yeah.
Money or shame. Right?
Money or shame, yeah. But everybody pays.
Sometimes I'd pay extra not to get the corporate swag bag.
That's a good option.
Is there a hacker swag bag, like instead of a corporate swag bag?
I just remember, like, one of my early black hats, or maybe one of the black hats I finally was like calm enough that I could actually look around, and Norse Corp was giving out like Viking hats and stuff. And I'm just sitting like, okay, this is black hat. This is supposed to be a big deal. Like this is like the pinnacle of the industry, and I'm sitting here watching people come out in droves dressed up like Vikings, and I was kind of embarrassed for InfoSec.
I mean, who doesn't want a Viking hat though?
I had a similar experience. My first black hat. I know that feel.
Yeah, Black Hat was really interesting this year. So I actually went to DEF CON this year because it was like 2 days before. It was the last couple days of the period where I thought the pandemic was over, right? So I gave a talk, which they made everybody pre-record.
I did remote training for Black Hat, but there was no way you're getting me to go there. So
I mean, that's pretty good precedent there.
I don't know. I mean, I had a pretty good time. At DEF CON, it's like they required everyone to have a vaccine card, and then they gave you like a wristband, and then they they wouldn't let anyone without a wristband into various parts of the the hotel, including the entire pool area for the whole weekend of the event. So it felt a little weird, like flying in and flying out, but when I was actually there, it felt all right. But the thing I really liked about DEF CON this year is that basically all of the people that were there were very dedicated. They basically did some like mental calculation, like, do I still want to go to DEF CON if there's some risk of death? And decided, sure, why the fuck not?
Yeah, I probably would have gone if it weren't for the whole like, oh, I have an infant.
Yeah. Well, you have a reason not to die right there. So, but the other wrinkle was none of the party crews showed up. Like, one of my friends who's a goon said, like, yeah, none of the looky-loos are here this year, but also none of the party people, right? None of the people that organized all the big parties. So there were like almost no parties. And as a result, all of the games were incredibly well attended, right? Because people were like going to bed relatively early and not waking up hungover. So like the Telefreak challenge and like all the challenges, like people really hit hard. So it was kind of like a big year for that. And the badges were really cool.
Yeah, that was a interesting
than the other way around.
It was like completely new people. They had like 3 months to throw the whole thing together. And Jeff was like, here's a bag of money. Like, everything's shorted, but whatever, figure it out. And like, if you don't suck, maybe we'll call you again next year. And they totally just knocked it out of the park.
They totally killed it.
Yeah, and was what I thought was hilarious is like, what's for the past like 8 years, what's the one experience that like everybody at every level has dealing with DEF CON is I went to DEF CON and got a paper badge, right? Because like heaven forbid, like when there's not shortages, like DEF CON know how to stock badges, right? Because that's just like this is the problem everybody expects now. And what's hilarious is that like in the land of mass shortages worldwide of everything, electronics most especially, right? Like pretty much all the speakers, all the goons, all the like CFP review people, all of us like backhand stage people that like didn't go, all got badges in the mail. So I'm like, oh, this is the secret to badges working, even under the worst of circumstances. We just don't let Jeff handle them.
Yeah. There were plenty of badges. Like, so I did a workshop and gave a talk, and I opted for badge payment for both of those. So I ended up with like 6 badges or something.
Yeah.
But they're cool because they each have clicky keys on them.
Yeah, and they're like cubes. You like hook them all together.
Yeah, they're cubes, and you can chain them together, and they can act keyboard, right? So I can actually chain all 6 of them together and use like you can play a multiplayer Simon game with them, but you can also use them as like I can like plug them into my DJ setup or something and just have a truly bizarre MIDI controller.
Streamer rig, right? Like
yeah, there you go. It's yet another project I probably won't get around to, but yeah, if anyone wants to play with a badge, let me know. So I mean, yeah, that was a questionable choice, but I had a good time and I didn't die, so
and your talk was really good.
Yeah, but they made me pre-record the talk, so the talk was available. This was super weird, right? So I had to pre-record the talk in like April or something, and so by the time I actually gave the talk, they released all of the pre-recorded talks as soon as the con started, and my talk wasn't until Saturday. So I had been walking around for 2 days getting messages on my phone like, "Hey man, saw your talk online. It was a good talk." Like 2 days of that before I ever gave the talk.
Uh-huh.
And then also like I'd kind of forgotten what was in the talk to some extent. So what I did before I gave my talk is I watched a video of myself giving the talk like twice in a row. And then went on stage and tried to repeat myself from April. It was a very.
There's been a lot of conversation on the review board about how usually like even in the under the best intentions and best scenarios, right? Like it's like buying anything, right? Like it always looks better on the box. You know what I mean? Like people get nervous and people freak out. Like I'm not saying that like people are intentionally diluting the quality or whatever, but like it just happens, right? Like there's more stuff in meat space. Like usually the after interactions are amazing. That's the thing that like no one can duplicate, right? But generally speaking, like the talk description is always slightly better than like what most audiences take away from the attendance experience. And this year it's like totally backwards, right?
Yes.
Because everybody was super paranoid that like, oh my God, it's just the video. I don't have the excuse of like, I'm going to go on stage and somebody's going to hand me a drink and I get to have conversations with people afterward. And it's really just about the after interaction. It was like, no, your whole experience is focused on this 1 hour video that you have to create by yourself. Yeah. And people like, I mean, I guess the anxiety was good for people aside from the probable mental stress is that like the quality is really good.
It was a heavy lift, but I actually kind of liked doing it way ahead of time because it was done.
Yeah, then like, you can show up and like enjoy yourself.
I showed up, I enjoyed myself. I went on stage. I had for the first time in my life, I had like no stage fright because in my head it was like I have already done this. This is already done, right?
Yeah,
they didn't even record the live talk because they already had the pre-recorded one for me.
Yeah, the team that handled all the pre-recording stuff, like, oh my God, props to that team. Like they really, because like when the plan, like the reason everybody had to pre-record the talk is because talks were already done and in the can before it was decided that DEF CON wasn't going to be fully remote again. Like the whole thing was like, kind of right up until the last moment, it was like, we're just going to go remote again. We don't know if we're going to be hybrid. We don't know if we're going to be hybrid. We don't know if we're going to be hybrid. And like, even when the decision was made for folks to go hybrid, like it took a while for the message to kind of reverberate through the planning folks. And like a common experience was, well, I guess we're going remote because I'm seeing us email speakers saying, if you're coming internationally, we'll deal with some extra hoops because it's the pandemic. And so like, that's a thing. And it was like, well, I guess we're doing like hybrid then, because people didn't know for like ever.
Yeah. Well, and actually, and parts of the DEF CON website actually had the wrong information about for a while.
Yeah.
Like there were delays in updates. So like even after it was like, yeah, we're going to, we're doing this partially in person, there was a part of the website that was like, it's still canceled. It's going to be 100% remote.
Yeah, that was hard because it was like, you have your regular, like there's still a SOC, right? But none of the usual suspects show up because pandemic. Well, that's not true. Like actually a bunch of the usual suspect goons actually did show up because they were like, if I'm going to die
almost all the goons were there. Yeah.
Yeah, because they were like, if I'm going to die for anything, it's going to be like, it's going to be like for my fellow goon, so to speak. Like they all kind of showed up to keep each other safe.
Well, I think basically goons show up ready to accept some percentage risk of death every year.
Not wrong.
Yeah.
Not wrong. But in this case, it was more like, it's been a pleasure playing with you, gentlemen.
Yeah.
It was a lot of that. Or people, like, I don't know, whatever gender neutral of gentleman is. And
gentle folk.
Gentle folk, there we go. But so like that was a thing, right? But then it was the whole problem of like, well, like safe mode really did pull together a kind of not completely different, but like completely different, like organically very tight-knit group of people running the Discord, right? Like that was like a whole thing. So now you have these like kind of separate, like somewhat well-oiled machines that now need to sync, and like that was why sometimes there was like website flubbage and like weirdness. But I don't know, man. We all expected a bigger train wreck than we got, in my opinion.
Yeah, yeah, for real. Although one of the funniest parts of the whole thing was, how they do the presentation at the end of like the, Mark goes up and talks about all the safety incidents.
Like the one asshole who was like, "What mask?"
Yeah. Well, no, all the incidents of like harassment and everything that happened at the event. So he gave a really, his closing ceremony talk was really, he's always super funny, but like, it was really funny this year because like all the numbers of, bad incidents were like all-time lows, which is probably related to the almost total lack of party.
Or just lack of party-induced looky-loos.
Yeah, but like all the people I actually talked to, I mean, it was a DEF CON, you just walk and talk to strangers again, and everyone I talked to was like super happy to talk about their like esoteric technical interests. There weren't any people who were like, "Oh, I just heard this was cool," and showed up and wanted to see what it was. Like those people stayed home, So
yeah,
like,
that's the point.
Yeah, everyone was there who was there like had some kind of mission, and I found it to be like really energizing.
Clearly, you've stumbled upon the key of the future. Is like whenever the quote unquote actual post pandemic occurs, the secret is we need to ramp up the messaging on DEF CON Plague. Like clearly the social message we need to send is that DEF CON Plague is so much worse than any other con plague, and if you value your life, don't go.
It's the DEF CON variant.
It's the DEF CON variant. Oh my god. T-shirts. DEF CON. Hashtag DEF CON variant.
I mean, it's kind of like DEF CON is canceled, right? But
yeah,
I think people have caught on to that one now.
Well, Fitz, I'm super happy to hear you're going to be at a tour camp with the fam, man. I'm like, I'd never gotten to interface with your kids before, except for the last event where they were there, and that was super cool because I had my oldest there, and now I've got two.
So was it?
We're going to try to head out there too.
Actually, that brings up something else I wanted to talk to you about. I totally forgot. So I think I want to say it was the last tour camp, although that's like 4 years ago now. But the last tour camp, was that the one where you did the drone taco delivery?
Taco delivery, yep.
You want to talk about that a little bit? Like how were you manually You were manually controlling the drones?
Yeah. It was a drone with a rope tied to it, and a basket hanging below, and we deliver tacos.
So people would like
pretty
call you
much-
up from other campsites and be like, I
Yeah.
want this many tacos, and you would.
So our phone number was 4taco. So you just dial 4taco for a taco.
Nice.
And we just made some tacos. Kids loved it. We let some kids fly the drone a little bit, but not too much because there's some precious cargo. We were thinking about I don't want to be like the taco drone guy forever. So we're trying to think of like different things to do and make it into a contest. One idea was like pneumatic tube burrito delivery.
Oh, I love pneumatic tubes.
But like that's not good enough. Like we need shitty pneumatic tube burrito delivery. Like where you get a burrito at one end and you just get a plate at the other end.
So you need like robot arms that unwrap the burrito on the way through, and
how do we make do we have like the burrito catapult contest, like where you try and get the burrito on the plate from across the field, and so.
Well, you put a burrito in one end, but it actually taco salad.
There you go.
Yeah.
And then the wild animals descended upon the camp and ate everyone.
Yes. Those deer are scary.
Yeah, another deer fact.
Yeah.
Try to imagine like a high pressure bean tube.
Oh man. So you were I remember I was talking to you about you like organizing the kids camp or whatever at tour camp.
Organizing's a strong word.
Well, yeah. I mean, so you were talking about how you ended up kind of running B-Sides Portland because everyone else sort of deferred, right?
Yeah.
That's also how I end up running stuff. It's like the only way I end up running stuff. For example, this podcast.
Same.
Yeah. It's
like, something. This is how B-Sides exists.
Yeah. So what time of year is B-Sides Portland usually?
It's usually October, late October.
Okay.
Yeah. So we took the year off. Everyone was delighted that was fine with everyone. So.
Yeah. Well, hopefully it'll be back next year, and hopefully tour camp won't get pushed back again because that's always a highlight.
Cool.
Well, so like at the kids camp last time, you had those like RGB lights in the buckets.
Yeah. Oh, well, so that was a Control H project, the Internet of Buckets.
Yeah, those were super cool.
Yeah.
Those Control H. Was someone there with a light table too? With the sand?
It's my sandbox.
Oh, I totally wanted to build one of those. So the idea there is you've got, what is it called? Kinetic sand?
So I put kinetic sand in there. So sand plus some silicone material that makes it a little more clumpy without getting moldy. It just makes the sand a little more clumpy. And then you have a projector on the top and a Kinect that does depth mapping. And it projects mountains and rivers and stuff. So I actually rebuilt it since that last time. I replaced it with an NVIDIA Jetson board. So it has a GPU. So it does all the rain simulation as well.
Holy smokes.
That's awesome.
Oh, man, I can't wait to see that. But it's so cool because like you go in the sandbox and you like make a little pile and it figures out because the pile is higher that should be a mountain, and then the projector above it like projects a mountain there, and if you make a like a lower area, it fills it in with water.
Yep.
It's man, I just love that thing.
I feel like if we can figure out how to make the grains of sand like magnetic and make the bottom plate like something like, I feel like we're close, right? We're close to like the sci-fi like
a tactile surface,
like physical projected like model thing.
Oh man, it has been such a pleasure to talk to you, Joe. Thank you so much for coming on here and sharing your wisdom.
Well, thanks for having me. Good talking to all of you.
Yes, it's can't wait to do this in person.
Yeah,
Yes.
I just wanted to say, like, you've probably been a pretty big force multiplier personally, and like hardware security in general. So, I don't know, props for that.
Thank you.
Yeah, absolutely. I think that you definitely helped me guide my path throughout the industry in the years that we've known each other. So,
well, I mean, I've just texted you stupid questions all year. And
Every
you've
time
been very considerate about explaining how to do basic stuff to me over many years, including this one. So
every
really
time I
appreciate
open
that.
up a cheap device and I find a UART console and I don't get a root shell, I always worry that it's my own fault.
That's pretty awesome.
Yeah.
Imposter syndrome is real.
It's true.
I'm actually not done. I have a whole bunch of questions for you now that I know about a certain device.
We should talk then.
Yeah.
Cool.
Well,
Thanks again.
Yes, that's been Joe Fitzpatrick. Definitely check out his site, securinghardware.com. And many of his other projects, I'm sure. The Tigard on Tigard, sorry. The Tigard on Crowd Supply, and look out for the Erebus, which are you putting the Erebus out on Crowd Supply also?
Most likely, but that's like a year from now, maybe.
Yeah, well, at the rate we get these podcasts edited, that might be that might be a current event.
Any day now.
Yeah. So look for the Erebus on Crowd Supply. Any day now, exactly.
Very interested in that project.
Man, how do we end these things?
Now,
there's that catchphrase thing.
Now more than ever.
Now more.
Go ahead.
Now more than ever, hacking is not just a crime.
It's a survival trait.